All right, for today, we're going to be reviewing TCP/IP, which is the Transmission Control Protocol Internet Protocol, or TCP/IP suite. It's the set of rules that were created to govern the internet. This is the way they're able to communicate. Without these rules, the mayhem of zeros and ones would not be able to do this. TCP/IP came along and actually, with these rules, made it capable to route traffic from one location to the other. Prior to that, it was obviously only on the lands. IP defines how each computer is identified in an actual network. You have your actual, as we saw yesterday in the video, the section on the right is where the host part is, and the left part of the IP address is where you actually live or the neighborhood. We're going to get into the details of how this is played. In this session, we're going to introduce the characteristics and the properties of TCP/IP. We're going to also present the purposes of the commonly used protocols that we have to learn, and both in TCP and UDP suite, and specify exactly which ports pertain depending on the actual application that we're trying to use. By the end of this lesson, ultimate goal is to learn and explain the purpose and role of TCP/IP in the internet and the private network itself, characteristics and properties of TCP/IP, explain the TCP and UDP ports, protocols, and their overall purposes. We have to understand exactly how TCP/IP plays its role in basic communication protocols. It's used to connect all hosts in the internet. Without it, there's no way these rules that they created to be able to format the data and create a specified way and route to be able to send all these zeros and ones across the network. TCP/IP addressing allows you to be able to use not only the old one, which is the TCP/IP version 4, but obviously the new one, which is the version 6. We're going to learn, obviously, the differences in how to notate it, and we need to learn how to read it. We can't, at this point, worry too much about the high def and how it is created, but we need to understand how to read it right now. That is the ultimate purpose. If we try to dig further into the actual TCP/IP, we will get lost. So let's concentrate in exactly what's going on. And at the same time, if you wish to learn, feel free after class, and I can play the 2-hour game as I did with many of my other students. And if you want to learn all the other parts, you can. But as for the purposes for this test, you need to understand the common protocols like FTP, SSH, Telnet, SMTP, DNS, HTTP, POP3, IMAP, to just say a few. Now, how? Adaptability is a must. And personal responsibility. Without my personal responsibility of ensuring that I am willing to learn and willing to put the effort, this is never going to stick. I can spit out any words you like out here and any other acronyms that you like. But unfortunately, if I say SMTP and you never read about exactly what SMTP is, you're not even going to know who OPP was. Therefore, the simple mail transfer protocol, for those that might have read, would understand exactly that it is port 25 and it is the one that sends out emails, for an instance. What is a protocol? As I stated a moment ago, it is the set of rules that is agreed upon when communicating electronically. In other words, that is the way it works and the way every single device on a network knows what needs to be done. Every given network device has a job depending on the layer that he sits on. Next, what is the TCP/IP? As I stated just a second ago, that means Transmission Control Protocol Internet Protocol. The TCP tells you in reference if it's going to guarantee or not be TCP or UDP, and the IP is the part of your address. What this means exactly, just like when you go to FedEx or UPS, if you want something guaranteed, you want it to be signed and said that it was delivered. Now, if you want to use USPS and put a stamp on it, let it go, that you can do too. That's what we call UDP on a network. It just lets it go and keeps on sending out information, but he can care less if it got there or not. TCP guarantees. How does he guarantee this? He sends it out and he waits. What did you get or not? The actual destination must respond saying, hey, I got this guy, I got this guy, I got this guy, I got this guy. He's like, oh yeah? Where's Joe? No, I never got Joe. Oh, here you go. Here's that piece. That's how he is able to guarantee and retransmit the information to that host. Without that actual reply back, it's never going to get there. So with TCP, it guarantees. With UDP, he can care less. What is the host? We have to understand that this is anything that's on the network, including the router, the switch, or any device that has an IP. We know that the actual switch, as we stated, does not need IP to be able to do his job. I need to configure IP to be able to remote and do any changes through SSH or whatever other type of connection that I'm trying to get to this given device. Any questions or doubts? Everyone understand TCP and the IP portion of the suite so far? Right. Let me drag you a little deeper, see how much you can hold your breath. In reference to a protocol, the protocol itself is the one that sets the rules on the network, depending on overall what you're using. As you can see down here, you have Apple Talk, you had the IPX, XPX way back when, you had your Net BIOS and the Net BU. These are the things that are on the actual network before. Obviously, now these things have faded away ever since the TCP/IP is on the internet itself. It governs the internet. All these people had to go and change their protocols to use the TCP/IP suite. Obviously, Apple Talk can talk to Apple devices. The IPX, XPX, you could still use that for the old token rings, but no one's using that. The Net BIOS also, I'm sorry, the Net BIOS is basically not being used anymore. But they all faded away and adhered now to these sets and rules. That's how it is able to talk. Questions or doubts? Still can use it, not being used. Right. Now, how does he do this? Now, overall, the TCP/IP model itself nowadays, I still remember Pidita. He's no longer here. Now he's only four. They got rid of the actual physical layer. They can basically include it in the first layer itself. But as for the actual understanding, this is where they are and how they play. What is the actual application itself? It lays all the way on the top layer. On the next layer is the transport. How is it? Am I guaranteeing it or not? Next is the actual internet, be that it is IP version 4 or 6 addressing. And lastly, on the bottom is your PPP, your frame rate, point to point. PPP is point to point. I forgot. Yeah, is it actually just point to point? I don't know. It's PPP. Frame relay is actual circuits. Ethernet is protocol. Also, thank you, point to point protocol. It was just too easy for me. I forgot the word protocol. Either which way, they all are on the network access layer. As I mentioned before, you have your NIC cards, which is your network interface cards, but you have your WIC cards, which is your WAN interface card, hence the word frame relay. It is looking exactly like the port of the Ethernet port on the back of a router, but it is actually a WIC card, which speaks in frame relay. Or if it is using PPP, it could be using PPP. Questions or doubts on these four layers? My application layer is where the application lays itself. Where, in other words, if I'm looking at a web browser, that's the application layer, HTTP, HTTPS. If I'm using email, that's POP3, IMAP4, or SMTP. Now, the next one right under it, that's the part that's actually saying, am I going to guarantee this transmission or not? Is it TCP or is it UDP? The next part of this actual network, every single part puts its information. For instance, on the top, he's going to put port 80. as part of his information and whatever his destination port is to identify to him that he means HTTP. Remember, what does a computer speak? Can he understand HTTP? He only understands zeros and ones. Therefore, I must give him the code 80. For you humans, I've decided to give you a nice little giggle word, and it says there HTTP. All of this is being transferred into zeros and ones, and how he does it is with these values of these numbers. We also learned that ASCII is our friend. Every character has a value. Therefore, that's how he sends every single character across the network. We know that from 0 to 255 represents the ASCII one, and then there was the other one, which I always forget his name, the one that was after ASCII, has much more characters like Japanese characters, and God only knows what other characters. Any questions, doubts?
Yeah. What does the ICMP4 version 4 stand for?
ICMP version 4 is allows you to ping an address. He is the protocol that actually is used to be able to use the command ping. And then ICMP version 6 is able to ping a version 6 IP address. That's the actual protocol. Like HTTP gets you to the actual internet site, the ICMP, which is the internet control internet control protocol. Internet, no, I'm missing them. Message. Internet control message. Look at that. It only took me like about an hour. Internet control message protocol. ICMP, but they're never going to ask you these names. You just need to understand what ICMP is. You can see that I haven't used the name for the longest time, so I always use ICMP. It is the protocol that's able to be used by network devices, routers, and on any other device to be able to ping themselves, in other words. It's the packet.
Okay, thank you.
Any other questions?
I better ask this man some questions.
All right. So now here goes the fun part. How does Humpty Dumpty get pulled apart and how does he get put back together? So now I'm here on the left side. This is me. How to look me, cute me. I'm typing away to the browser. The browser changes all these zeros and ones so that the OS can send it to the network card. It comes out as electricity out of this port, all similar to the old Morse code. Every single language has its own Morse code. If it's Ethernet, it has its own. Frame relay has its own signaling. It's all electronic signals. Depending on the actual signal's voltage is where the zeros and ones come into play. It gets sent out through the copper into the internet or the cloud, as we see here, when it obviously is going through a router. It goes out, gets to the next router, and eventually gets to you, which now you put it all back together again. But what's happening here? See, this is me actually creating a package. Just like I want to do when in Christmas, for those that do Christmas or your birthday or whatever you celebrate, you wrap the present. Therefore, on the left side, every single layer is putting their own part of their own information. I'm asking for a site. The application layer is putting actually 80. The next one, which is session, is saying TCP. I want to guarantee this. The next one says, here's my IP. That's the IP I want to go to. The next one gives me the actual MAC address of me. You see how I'm actually adding information? It gets bigger and bigger, but by the time it goes out as bits. It breaks it up into all zeros and ones. It's all bits going across. When you get to the other layer over here on the other side, he's able to receive the Morse code, decipher what's going on. He removes his pack part of it. So he'll remove the MAC address part of it, pushes it up to the next layer, which says the IP, and or each one starts now unwrapping the gift and saying, yeah. And then now he says, oh, you just want that? All right, here. Now he starts wrapping up the gift and he does the exact same process the other way around. That's how it gets done. Everybody feels important because everybody gets a gift. They get unwrapped, depending if they're sending or receiving. Questions or doubts?
Did everybody understand that? Like, did you actually understand what he just said? Nobody's
No,
making
no.
somewhat.
Right.
No.
I also
Okay,
I have a
let's go
Mike
back.
Myers video I can show after class
Yeah,
that kind of breaks it down too.
we'll show you. There's a little GUI and everything that we could see. But what I'm trying to say is, on your hard drive, when you're asking your hard drive for information, the application that you're using does not have to do anything except for retrieve the information. Do we all agree? Now I want to go ask somebody else for the exact same thing that I wanted, but it's somewhere else. The only way is if the application tags itself. So now the application layer is going to say port 80 is where I want to go to this guy. This layer is going to tell me what's his IP address and what's my IP address. I'm going to also say what port I want to receive it on to my computer. Now that I've tagged that information here and I have my IP address and I have the MAC address that I can send it across the network. When it gets sent across the network, it's able to identify who I am in the network and where I want to go into the network, because routers have tables that say how to route traffic. Even if they don't know where it is, they know they must pass it to the next router in their hop that most likely will figure out how to get there on its own, because every router has its own routing capabilities. Now that I got out of the cloud and I finally got to your building, this here must remove, and at the same time is keeping the information of MAC addresses and all this information, but it's removing it because it's unnecessary information for the application to read. It doesn't have to read that information. The OS does the same thing with the TCP/IP. It still is keeping track of this information because as soon as you create the initial tunnel, it already then assures that session is up and running. Now that it has this information saved as a session and that the virtual tunnel is up and running, it continues to go through this actual process and requests your information to the actual application server. The application server now knows who you are, and we could actually play that he's on this side. He must now indicate the port that you said that you were going to be, the IP that you were or are, and obviously include hopefully the MAC address information so that it's easier to route the information when it's going down. This is so that all network devices know how to route the information. After that, the PC does not need it because he does not need to route information. That's why it gets taken apart and only reads the part that's necessary of the application. There is some videos we're going to see also inside test out that also tries to help out in little GUI representations that hopefully we have from that other guy. I forgot his name. Questions? No? Maybe? The more we repeat it, the more it's going to start to hopefully sink in. So, as we stated a moment ago, each one has its own set of rules. HTTP is used to be able to communicate to web servers. So whenever I say port 80, everybody in the network, even the device that's receiving the information, is fully aware of the service that you're asking for. As we said, there is clients and there is servers. Each client is asking a server for some information. And in this port, since I'm asking for specifically port 80, when that server receives a packet, he knows exactly which application needs to be used. What service are you asking for? Next one here we have is TCP, Transmission Control Protocol. That is the one, as I stated, that manages every single conversation. He divides every piece into smaller segments, And he also ensures that it gets to the host. And if it hasn't gotten there, that he resends the information. Questions either on HTTP or TCP protocol. Next one is the IP, or the Internet Protocol. This is responsible for taking all the formatted segments. So now that I have the pieces, as I said, now that I added that I want to be guaranteed, I'm going to slap on the IP information. So all these encapsulated to them into packets, assigning them the appropriate addresses and the delivering them across the path in the best, most reasonable way with the least hop. With IP, it's able to go to the router and say, okay, you have maybe 5 different ways to get out of this facility. Which way is the best way to get there? It does this automatically, and it's always updating itself. Questions or doubts on IP? Your next layer, we're going down the little rabbit hole, is your network access protocols. This is the data link management protocols. It takes all the IPs and it formats them to be able to be transferred over the media. It creates the signaling of the zeros and ones. It had be in fiber, be in light, or in electricity when it's in copper, to be able to be interpreted by the receiving clients. We then switch going out to the routers. All this signaling goes into play. Questions? No? For real? Okie dokie.
So nobody has not one question. Marvin, Kelly,
I guess when we
anyone?
watch the videos this afternoon, maybe might get encouraged. I'm not sure. And maybe the
What was your
video
question,
that
Christian?
we have.
Huh? Repeat that?
His question was that if
What was-
that nobody has a question.
What was your question, Christian?
Oh, no, I'm just saying, does anybody actually have an actual
Okay.
question?
I have just a simple, this doesn't exactly apply, but just to get an idea. So we've got the message, and each message, each single bit has to have the header address to it, or does it start some sort of a tunneling system, or exactly? Because it seems like if you have to have all the address information and the data each time, it seems like that's going to be a really big packet, or is it?
Yeah, you
Well,
are correct.
you
It
get packets and
is.
frames outside of it.
It keeps on adding to it, like you said. But when it goes out the hole, it's Morse code. There's only a bit at a time. So he stores it on the device. These things have big memory mounted onto them. So the switches, the routers, all these things have capability of buffering this information. This is why we always say you're as good as your slowest link. And therefore, depending what you have on your network is how fast you can go, and your connection itself. So by the time it gets to the switch and he has all this information, he's buffering all that information, but he's sending it out just in pulses of bits at one zero or a 1 at a time. Any other questions? So when it gets to the other side, now the switch, that switch does the opposite. He starts receiving all the zeros and ones, and now he goes and starts putting or encapsulating that back into that right size of, so that we can go into the IP layer and then start removing the information of the IP layer, and obviously so that the application gets his information that he only needs, because the application is not going to understand all those extra zeros and ones. So he just strips that information off because the application doesn't need it. Does that make better sense? So when he receives it, he starts buffering the message, Just like when you went to old Morse code, that it has to wait until the beeps comes through to be able to decipher if the letter is an S, if the letter is an O, or if the letter is an S. It does exact same thing. When it receives it, it knows how to create each into a byte and or whatever it is creating. We just need to understand what it does, not how it does it.
Mhm.
Because if not, then we're gonna have to become switches or routers ourselves. Don't break your heads over it. Just understand how or understand what it does and the process of what it's doing. And how in the details of how it does it is very difficult to explain and decipher. We just need to understand the actual layers of the TCPI layers that we're identifying. That is going to help us later for the troubleshooting and identifying which device we should be going to. As long as we can understand where each protocol lays and who is responsible for those protocols, it helps us to be able to determine exactly where the fault is on a network. Any other questions? All right. So the IP address itself contains, depending obviously the version 4 or 6, it contains a subnet mask, and you have your classes, you have your public, your private IP addressing, you have your APIPA, and overall different types of communications. For your actual IP address, it is, as we stated, the unique identifier for any given device. It identifies exactly what is the host number and the network he resides. IANA is responsible for tracking all assigned public IP addresses. As for private IP addresses, we all get to have fun with those. Anyone can repeat any private IP because it is not routable over the internet. The router will never, ever route over the internet a private IP address. It will do it over the intranet, but it won't do it over the internet. As for IP version 4, that uses a 32-bit addressing. As we learned, there are 4 octets of 8 bits each. Within all 256 options, because 0 is a number, so 0 to 255 is the actual possible. Within the actual IP version 4, that is about 4 billion, about 4 billion unique addresses. And inside the 128-bit, the most thing that we need to remember is that it is hexadecimal addressing and that it is 128 bits versus the 32 bits. Much more larger pool of addressing. Questions or doubts? The book is going to teach you guys exactly which are the readings, if it is a valid address, if it is similar to an APIPA address, if it is a loop back address, all that we must be able to decipher. So is the labs. So if when we review the labs, you'll see in detail exactly what are the type of IP addresses and how to read those IP addresses. As for the subnet mask itself, my friends, he's the one that's able to divide the actual number that's on the top. Just like the zip code helps the actual postal code be able to figure out what is 128 Elm Street. That could be anywhere USA. With the actual zip code, I'm able to decipher where in anywhere USA I am, and now I can know which 123 Elm Street I'm talking about. The actual subnet address contains a series of ones or zeros afterwards. Now, it is filled up from left to right on the bottom. So you'll see usually 255.0.0.0, for instance, for any default class A address, or 255.255.0.0 for any B. And lastly is the C itself, which is the 255.255.255.255.0. What is easy about this is hopefully we all learn binary by now. If we have learned binary by now, we will know that the 8 bits, the highest number that I can get would be 128, which is the first one on the left out of all bits that are available to me. Now that I know that 128, if I turn that on, it is the next layer or the next class. Hopefully that helps me. So what does that mean to me? 0 is where I start. 128 is less than 128. Then that means 0 to 127 must be class A. If I turn on my second bit, I should know by now that it is 192 because 128 plus 64 is 192. Now that I have turned on my second bit, hopefully I know where my range started from and remembered it was 128 and it must be less than 192. Now that I know that it's less than 192, that means 128 up to 191 is class B. Lastly, if I turn on the next bit, it will be 224. Now I know that the next range starts there, so that means it has to be lower than that one. So 192 to 223. That is my class C. This is the first octet, the first number within the IP. So 0.0.0.0 is an A class address. 128.1.5.255 is a class B address. Anything in these ranges is how you know exactly what type of class it is. Now that I know what class it is, this is the default minimal subnet mask. For a class A, the minimum I can put as a default is 255.0.0.0. When I'm in a B class, I lose the first 2 octets. And when I'm in the C class, I lose the first 3 octets. So I could only have hosts, which would be the last number on the right. That's what it basically means. So then anything in a class A, if I have this default subnet mask, anything that is in this first octet is the network, the neighborhood that I live in. Then every dot, as you see here, I have 3 zones, are all the houses in this neighborhood. That's a huge neighborhood. Class A neighborhood is equivalent to a metropolitan area. A class C is like a little cul-de-sac, small, can only have so many, only 256 possible choices, which you lose 2 for the host one and 1 for the network. So technically you only have 254
Hey, Diego,
in that neighborhood. Mhm.
I'm lost in your neighborhood right now, man. You like it's yeah.
All right,
Can you
here's
run
10.
this real quick again, huh?
Here's 10. Dot 216
Mm-hmm.
dot 8.1. The first number here tells me what type of class IP I'm dealing with. That's the first octet, the first number on the IP. Now that I'm looking at this number, it has to be within whatever range. Where is 10 in this range? It's less than 128. So that means that this IP right here, his class, is a class A.
Okay.
That's now that it's a class A, this means that all of this over here is available for houses. This is the neighborhood. These are all the available addresses in this neighborhood, all the different houses. So I can go from 10.0.0.0 up to 10.255.255.255. All those people live in this neighborhood.
How far?
Versus, now look at a class C. Look at what happens to the class C. The class C, for instance, if I put 192.168.2 dot 192.168.2. Stop drawing. Really? Can I get my pen back? No. It doesn't like my drawings. Let's do one more try. There we go. He's back. Dot 1. We said this was my neighborhood on a class A. Look at my neighborhood now that I live in. That's the name of my neighborhood. And over here, sorry, 192.168. So I lose this octet, I lose this octet, and I lose this octet to represent the neighborhood that I live in. And there's only this octet that I can have houses. So from 0 up to 255. This
So
is the
quick question.
network address. Mhm.
So if I had an IP address starting with, like, say 128,
Okay.
I would be in class B, but would that be my place within the network?
If your address starts with 128, right? And your
Yeah.
default subnet mask was 255.255.0.0, then if your address starts with 128 and whatever is the next octet that's there, that next number that's there, it will give you the exact address of where he is.
Okay.
So the first two numbers will represent the neighborhood or the network that you're in, and then the last two will represent your house number.
Okay.
So depending on what class you're in is how that number gets divided into pieces to represent either the neighborhood or the house that you live in. Does that help? That's the way it's able to determine what type of address and how to break that up. As for these right here, this is how it breaks it up. Now that I put straight ones across on the bottom, that's the 255. That's the 8 bits on. When I turn on all 8 bits, I have 255. Now, the same thing happens here. So what happens is it knows, since I already turned on all these bits, this side of the address means that that's the neighborhood you live in. Anything after what we call the virtual wall, where the last time 255 comes out, that's exactly where the actual number of the house pertains to. Your number. So each one gets broken up in these different phases. As for your class D and your class E, the most important thing that you need to understand is D class addressing is made for multicasting, and class E is reserved to the military and experimental use. That's all you need to know. There don't need to know what type of, there's no default subnet mask, none of that mumbo jumbo. You just need to know that that's used for multicasting and the other one is used for experimental use and or military.
What is multicasting?
Multicasting is one person sending out a broadcast message to a set determination addresses.
Okay.
Similar to a spam.
If
But
you're
he already
watching a
knows
video
who he
presentation-
wants it. He already knows who wants it.
If you're going to watch a video presentation for a company, it may be that one person is going to send it and 50 people are going to receive it. It is a one-way communication.
Mhm.
From a single point to a defined number of other points.
Mhm.
Did y'all understand that? I did. So,
You did or you did not?
no, I did. I definitely did.
And that's across the internet. That's across the internet, obviously. That's already in the internet. That's all public. Happening
But
up
you
in the
said
public
class
internet.
E is for reserved or
For
for experimental use.
Reserved for military purposes and experimental use.
So we don't even have access to that then.
No. No, you just need to know what it is and that's it.
Gotcha.
You're not touching that anyways. Unless if you get a military job, and then you'll find out how they use it in there.
Be the next Edward Snowden.
Questions or doubts so far? As for the last column on our right is a shorthand way of writing it. What do I mean? As I said, each section has 8 bits. Therefore, if I have 255.0.0.0, I turned on only 8 bits. Hence, I can actually just write /8 next to your IP address, and I know exactly how to write your subnet mask. If I write /8, I turn on the first 8 bits. Therefore, it's equivalent to 255.0.0.0. Everybody remember how to do binary? Because I could see the deers all across the board.
So, Kelly, could you explain binary real quick in the most simplest terms?
Okay, simplest
It's-
terms. Binary essentially on and off. When you get to IP addresses, you see I have the 4 numbers separated by a dot. So like in the class A, you see 255.0.0.0.
Mhm.
Okay, each one of those numbers that is separated by a period is 8 bits. So it's 8 zeros or ones. That combination will give you that number. If you turn all of them on, you get to 255. Does that make sense?
I'll show it.
So-
Actually, you know what? Here we go. Let me get the Excel.
You going to ending?
Excel sheet out. Yeah, I'm going to show them the ending one. That's the only way this is
Okay.
going to sink in. We have that one somewhere around here. Give me 1 second. We put that in the Google Drive, right?
It's in your share drive.
Thank you. All right. You wanted to go into the rabbit hole. Here we go. Here's just one little part of the address. This is 8 bits right here. Here is the first bit. It is 2 to the 0. 2 to the 0 is equal to 1. So each bit, as you'll notice, goes and multiplies itself and gets bigger and bigger and bigger and bigger. An address only has 8 bits. Since the first bit is 0, it's here and it goes up to 7. This here is the number representing what bit we're on. This is the actual value of the bit. And when you actually turn it on, this is what he sees. Now, what do I mean by that? Watch what I do this. If I turn these 2 off, automatically he knows only to turn on this bit, and that means it equals 128. That's my subnet mask or my IP address at that moment, whatever it is that I'm creating. If I turn on the next bit, it adds itself, oops, sorry, wrong place. This guy here, right? And on this bit, it adds itself and creates 128 plus 64 is equal to 192. And this is how he's able to create the numbers. Now, look at what's even cuter than this. If I do this backwards, which is the way the hosts do these, watch what happens. If I turn on this bit, my number is 1. If I turn this one off, but I turn this one on, my number is 2. Now, you're gonna notice a pattern. If I turn this one back on, I become 3. If I turn those 2 just off real quick and turn back this guy on, I become 4. And the pattern continues. I become 5. Sorry, 0. And then over here, if you'll notice that was, oops, sorry, that's 1, 0. If I turn this one on, he becomes 6. This is how he's able to create numbers. By turning on or off that bit that he's going to send to them, he's able to create a number. 8 bits at a time are being sent out, or a whole byte. So the network starts from left to right. the host starts from right to left. That's how he writes. So that's why they say that the wall starts from the left, and hence the 255 here. Because if I turn on to reserve for the network, if I want to reserve for the network this octet, it becomes 255. Now I turned on the actual subnet. Now, my trick of reminding everyone, if they could just play with this little chart and fill it out slowly, they'll notice that these subnets do go from 128, they go to 192, then they go to 224, sorry. After 224, it goes to 240. I keep on hitting the wrong place. 240. After 240, it goes to 248. After 248, it goes to 252. After 252, it goes to 254. And after 254, it must go to 255. As you saw, I purposely delayed so you could understand that I had to memorize these numbers. There's no other game except for memorizing and how this number gets turned on for the subnet. All you need to worry about yourself, though, is that the default subnet for A is 255.0.0. That means anything to the left to this way is reserved for that type of class A. The next one number that I should memorize is the 192. So now I know where these numbers split. See, it starts at 0, 126.255.255.255. Why 126, Diego? Have you gone mad, Diego? You just told me it was 127. What's wrong with you, child? That's because, my friends, if we read carefully, 127 is loopback. And if we recall, the default subnet is 255.0.0.0. So the whole subnet of 127 is loopback. Any address on 127 dot anything is a loopback address to yourself. Hence, the only usable addresses will be from 0 to 126. Yes, 127 is a class A address. It's just not usable. Questions? Did that help a little, or did I just confuse you? Because I can show you ending, and that'll really torture you. I'm trying to make it as simple as possible here. It'll
Is that
get
something
real
that we
confusing.
could play around with if we copied it to our own drive, or are you guys not allowed to share
Oh
that?
yeah. No, we give this to you guys. We
Oh,
just
perfect.
save this to make sure you'll be able to play with this. And as you'll see here, here's the IP. Ending is how it's creating it. So you'll see here now, here's my IP address. So let's go and create any IP address that I like. For instance, 00128, right? So now 128 is my IP address. Now over here, you'll notice here's my actual network where I reside, right? This is where I reside. So this is my neighborhood address, my zip code. This is my zip code here on the bottom. Now that I know the neighborhood that I live in, it's able to decipher. How does he know my neighborhood? My friends, that's the wall. If you'll notice, if I start turning off addresses, the wall will start moving. I'm going to purposely use, though, a class A address because this Excel sheet, I actually made it smart enough where it won't let you mess it up. Therefore, it won't let you create a subnet mask that you're not allowed to. Let's create a 1. Now, a class A is able to actually break himself into smaller pieces if he feels like it. The default minimum is 255.0.0.0. But I can break it up into smaller pieces if I feel like it. It's up to me at that choice. Depending how the wall is filled out, then the number on the bottom gets changed. You'll notice now that my last row, if I leave it with the default subnet mask, the network that I am in is 1000. CIDR 8, that's that bash, that slash that I told you earlier. CIDR 8, why? Because there's only 8 bits on. Now I want to go and play a little further. Always, we have to turn the left bit on first. And you'll notice now, while I go filling it out, it'll start to change. Obviously, something's wrong with the formula here. Somehow, somebody broke it. It's not getting that one up here. Why? God only knows. We'll go with it for now. It's supposed to turn it on, but you feel me. No? Oh, that's right. Never mind. That's the number up here, 55. That was my fault. Dummy me. Now, how does he do this? He'll multiply. 0 times 1 is what? Please humor me. 0 times 1.
0.
Okay, so he took this bit, he multiplied it by the subnet mask, and he came up with 0. Yes, you wanted to do this. Next one. 0 times 1 is 0.
0.
Now this bit is on. These are the bits that are on to equal 55. You see that up there? Now 1 times 1 is equal to the bit's 32. So if I turn them both on with a 1, since this bit is equal to 32, he brings 32 down here. Now, my friends, that is the ice cream truck. The most important, your IP address, if I change the subnet, it'll change what network you're in. You see down here, this here, the bottom, I have, this is my network name. My network name is 1.0.0.0. That's my neighborhood, where I live, equivalent to your zip code at, right? But this is the actual unit number, the 55.218.4. So you said, can I have that same number repeat itself? If it was a private one, I can do that. If I break it up into different pieces, that number can exist duplicated, because in a private address, depending who and how it's being divided is how it happens. You get to choose that. But by default is what we need to understand, because if we go back again by the complicated that you could actually break it up whichever which way you want, that gets more harder to be able to identify where it breaks. By default, any class A loses this right here completely. Then class B loses the first 2 octets. Then class C loses these 3 octets. Depending on what bits the network or the subnet is turned on is how it gets divided. So you'll notice this 10.55.218.4 is my IP address. And this is the actual network or the neighborhood that I'm in. That's my zip code. But watch what happens when I go and change and make I break this into smaller sections of networks. When I actually do that, when I start adding this here one by one, you'll notice that at one point, depending on how I'm dividing it, this number will change. Now the neighborhood or my zip code in this case is 10.32.0.0. But my IP address has not changed. My IP address is still 10.55.218.4. All I did was just change the subnet mask. And now I moved from a different neighborhood, a neighborhood that's broken into more pieces. You'll notice there's a total of 8 possible networks. And these are the hosts. Questions? Doubts? So the subnet mask is where he divides it. So we need to understand how to read the subnet mask. They're only going to test you on valid subnet masks and default subnet masks. As long as we understand 255, that means that whole octet is reserved. And then again, this whole octet is being reserved. Then this would be the network area. And then over here would be the actual host. And every change here would create a brand new network. Wherever the default subnet lays is where the network is broken compared to the host address, what the building number is. Any other questions? So from our classes, we just learned that it was 0 through 127, but usable is up to 126. Since loopback is completely lost, the whole thing is lost to loopback. It's a class A. So my whole first number is reserved. Anything on the right is the host address. Therefore, anything from from 127.0.0.1 up to 127.255.255.255 is a valid loopback address. It's completely reserved only for loopback. As for my private IP, what I need to learn is now that I'm in a class A, the private IP is 10. Therefore, I could only use 10 on the first one. That's the only private one that I have in a class A. And since I know I'm an A, anything that's beyond there to over there, I can use for any host. So I can use from 0.0.0 up to 10.255.255.255. I can use all those IP addresses all I want and how I want.
Is there any reason why 172 and 168, or sorry, 169 are private?
Yes, good question. The 172.16.0.0 is the private IP address that you can use as a company for yourself. Now, for Windows, they created what they call a PIPA. A PIPA was their solution when you don't have a DHCP server who is answering. I want to be able to talk still. I may not be able to do anything else, but I want to be able to talk. I have to talk in IP. So now that a DHCP server didn't answer me, Windows reserved that entire range. Anything inside that range is a valid APIPA address with the default subnet mask of 255.255.0.0. So all the computers in this building, since they lost the DHCP server, are still able to talk to each other. They won't be able to, unfortunately, talk to any static IP because the static IP has the valid IP that should be inside this private network. Hence its conundrum. Whenever you get a call where everybody is able to talk to everybody, but they can't get to the printers or the server, something probably is wrong with your DHCP server because everybody that's looking for DHCP has an address and they can't get out because it's only inside that building.
So question, so the class Bs, you say those were for businesses?
Anything else that's not, anything that's not private is a public IP address that anyone can purchase. Anything that's private, anyone can use privately, be for business or for personal use.
Yeah, because my IP address is 192.168.
Mhm.
something. So mine will be a
Mhm.
class C private network at my house.
Correct. In other words, now that we know that, if I reserve these three over here and we come back over here and we turn it on, now you can see why I stated earlier, your IP address, you'll probably notice you could only have so many. If you can get into your router, it's going to say you only have 254 that you can use. Why? Because in the first IP, you always lose it to represent your zip code. What is my network name? Where am I in the world? And the last IP, you lose it to the host. Who is this host that I speak of? The broadcast address. Each little segment has its own personal broadcast address to be able to scream to everybody in the LAN. If I don't know what my LAN is when I scream out all 255s or all Fs in MAC address so that I can have somebody ask for me through the DHCP server or whoever I'm trying to broadcast to give me something. Questions? So you'll notice here, then in the class C, it changes here on the third number. Any change on the third number would be a complete new network.
Right.
So 192.168.0.0 is the first network. 192.168.1 would be the next network that you can use.
Mhm. And it's dynamic, so every time I log in, it'll change.
Yes, depending on how long your lease is with the DHCP server, he leases the IP to you that many days. And if you never confirm that you're still using that address, then if necessary, if he runs out of usable IPs, he assigns that IP to someone else.
Mhm.
So we need to understand, how is it that this works? Your social security number represents you. So let's go back to this envelope. When I send something to you, would I put your social security number? No, I put your name, right? Now, how do I get it to you? I put your address and your zip code. What happens though if I went and used your social security to send everything and you moved from one location to the other? How do I know where you are? I can't use your social security number. So then again, I put your name and I put the new address that you decided to move to. Now I know how to get there. With that number, I know every single router knows where each given IP is. I can't get into details, but each country and every company has its own reserved set IPs. So these routers have tables that give them the answers on where it needs to go. There's no guessing game. They know exactly which route they need to take. And they also have, obviously, since it's in a mesh network, if one of the direct routes is down, it can obviously use any other route to get there. Does that make sense? So 10 is the class A for private. Anything else between the 0 and 126, since I lose loopback, which is 127, is a public address. So if I gave you the number 365.10.55.278, is that a valid IP address? 365.10.55.278, is that a valid IP address? Anyone?
No.
What's the, okay. So now we know how to read. Valid number would be 0 to 255 because it's only 8 bits, right? So the only number that they can give you on that screen, if they're going to ask you who's the valid IP, you should be able to know it. Now, if I told you that the IP address is 132.16.55.22, is that a public or a private IP?
That's going to be public because it doesn't start with a 10.
And it doesn't
Oh, wait,
start
what
with
was
a
the first number?
172. It didn't
Oh,
start
it
with a
was
10, you're correct. And it didn't start with a 172.16, right? Or between 172.16 or up to 31, right? And then the last range we need to memorize the 192.168, right? Because then
Okay.
that you can use anything else. As long as you can remember which are your valid IP numbers for private, everything else is public, with the exception with a pipa and loopback. That's why in this chart, I make sure I give you guys the loopback, because obviously loopback, as I stated a moment ago, is up to.
And if you
You got
could, is it possible for you to reiterate what a pipa is?
Yeah. A pipa is Microsoft's, oh dude, I just put less than what I was supposed to. 1, 2, 3, 4. Microsoft's solution of when you do not have a DHCP server. A DHCP server gives every single computer on the network a valid IP automatically. You can reserve static IPs. In other words, you can reserve your IP and say, I'm never going to change it. Or you can let a server dynamically give you this IP. So now, If the DHCP server fails, or somehow you cannot reach the DHCP server, because when you turn on your computer, it broadcasts to the network, I need an IP. If it is set to DHCP, it screams out all Fs in MAC address, or it screams out 255.255.255.255, saying, hey, I need an IP address. I'm just in layman's terms, but it's just as good. Now, the DHCP server replies back and says, since now I have your MAC address, I replied to that MAC address saying, hey, this is your IP address while you're here. If I can't do that, Windows decided, hey, instead of no one being able to communicate to no one, a PIPA is my solution. The computer himself will choose an APIPA address. And amazingly, somehow they talk to each other on the network and ensure that it doesn't duplicate itself on that given network. Now, APIPA addresses will not leave the building. You will only get an IP address and a subnet mask. The default subnet mask for IP for a class B is 255.255.0.0. But you won't get a default gateway, because the default gateway would be in the previous address, which would be whatever other real address you're supposed to be in. So its solution only fixes so that you can talk to each other. You won't be able, most likely, to send a print job to a static IP. You won't be able to talk to anyone but the Windows computers themselves that are all in that APIPA network. Horrible idea, good idea. Yeah, gives us the what's great about this is that here we right away we're able to tell that all the users on the network are able to use their network cards. They're able to get to the switches. There's something that's impeding them to get the IP, and if we know that it has to be a DHCP server. So the information is not getting to him. If the DHCP server doesn't happen to be on site, then obviously it may be the router or the network the actual external networks that's down. But in most of these Fortune 500s and these companies usually have a DHCP server on site. Hence, your Soho routers at home have it built-in DHCP server. Any other questions, doubts? All right. So, put this back the way it was. Are we sure? I can hit next. We sure. We can please post. Please do not edit it. Just download it. I'm not if we can post that so that they can get to that ending worksheet.
That's
We're
gonna be
here
in-
also.
I've already
That
put
should
it in
be
the chat.
Okay.
Okay.
All right. In reference to the areas we just covered, and this is, as we said, the shorthand way. So as we notice, each section has 8 bits. Since I have 255, a shorthand way of humans writing it, the lazy ones, usually network people, write it that way with a /8. It's much easier than writing 255.0.0.0 because we're lazy. Remember, IT, we like to be lazy. Once again, here, 255.255.0.0, there's 16 bits that are on. So /16 and so forth. 8 plus 8 plus 8 equals 24. Questions on the shorthand way of writing a subnet mask? Shorthand way of writing the subnet mask? None. Okay. So as we alluded to earlier, as for a class A, there is 126 networks, as I stated, because 127 is lost to loop back. So therefore, from 0 to 126, there's available networks, which means that there is 16,777,000 1,214 available hosts, and so forth. Obviously, and depending on the actual company, you would choose between the A class, B class, or C class, and from there you will build your network. If it is a large company, you would be using a class by default. If it's a medium sized company, you can use a B, and if it's a very small company, you can use C in reference to the sites themselves. Remember, this is how we create LANs. So if we're creating an intranet and we need a lot of places, a lot of IP addresses, although there might only be 250, I may use a class A address, a 10 dot something, but maybe break it up into smaller sections, as we alluded to earlier. Once again, depending on how you want to do it, you choose your class of private IP address. And then from there, the same thing if public, if you need so many, you can choose that also. Top one would be large, medium, and small companies or small sites, depending how you look at it. Questions? As for the public IP addresses, that's the IEEE assignments is used for public IPs. Usually your ISP will give you one of their reserved IPs that they're able to use to be able to facilitate you getting onto the network. As we stated a moment ago, 1 through 126 are for very large networks, 128 through 191 is for medium networks, 192 to smaller networks, and as lastly, the last two are either reserved for multicasting and or for military and testing purposes. Questions? All right. So, IANA have reserved certain IP addresses, as we stated before, specifically on the network. And here's your class A, B, B, and C. As we mentioned, the 169.255.0.0 is the APIPA address. So anything that starts with 169.254 is, since it's in the B, anything after that would be any host, would be in a APIPA address. Automatically, then I know there's got to be something wrong with my DHCP server, or maybe the router is not routing the traffic correctly to the DHCP server. Questions on any of these? Grand Central Station, I'm all right, direct your call. Questions? We do understand, as I mentioned before, we always lose a network address and a broadcast address. In this case, that means always, always, no matter what you got, 0.0.0 is unassignable, and neither is 255, 255, 255, 255. As we know, 255, 255, 255, 255, we mentioned a moment ago, is the broadcast address for every given network. So I can scream out to everybody. Obviously, every subsection has its own network uh, broadcast address also. Therefore, since the first network starts on 0.0.0, we have lost that first one to the network. We can't use that to assign that to a computer or router or anything. That is the zip code for the first network. Question? All right. Apparently, it's time to climb.
Oh, I don't have the Nearpod. Is it in chat?
That will be Baker Kilo India 3 Delta. And let me see if I can copy that.
I just dropped the link.
Thank you.
Alright. Are we missing anyone? Everybody here?
Looks like we got everyone.
Okay. So, so /A, is that class A? B? Divide by 8. I love that. I think it's divide by 8. I don't know about anybody else. All right, I think that'll help. I could just choose. That way, if everybody's already chosen. It's definitely the number of days left in class. Definitely agree. Ah, I got it wrong. Darn. What we want, we can only hope. Hmm. 255, 255, 255, 0. Jupiter and Venus. Yes, that's got to be when they align. It's got to be it. It's got to be. It's aligned on the 5th house. Well, congrats. Hope that was fun and exciting. As we mentioned a moment ago, and PIPA is the feature where automatically private IP addressing that Microsoft added to the TCP/IP suite. A PIPA is assigned when there is no configuration available for the computer. It is a /16 network, and it starts with the 169.254. Anything after that would be obviously the actual host IP. Questions or doubts? Okay. Now, your types of communication is a unicast. Unicast means that it actually travels in a single source to a single destination. Your broadcast travels from a single source to all destinations. As we see here, the one for all is 255, 255, 255, 255. But if I want to go just inside my LAN in my building of my neighborhood, instead of broadcasting to the world, I only want to do it to my neighborhood, then obviously, depending on the neighborhood, I will use the last IP that's available on that to be able to broadcast. Questions or doubts on a broadcast address, which is everything on the neighborhood, including the world, and a direct broadcast will only be the ones inside your network. If you're doing your broadcast address, obviously, whatever that given network. Now, for multicast, travels from a single host to a specific multiple destinations. A Class D makes this possible to create the multicast group, which already has a defined, it's already defined. When you have that multicast address, it's defined where you're going. Questions or doubts? Now, as for IP version 6, this has 128 bits expressed in 32 hexadecimals, divided into 8 fields or sections. Obviously, the way to be able to shorthand this, they facilitated that anything that starts with a 0 is omitted. And how do they do that? They'll put the letters corresponding. So whenever there's a whole lot of zeros, basically you'll put 2 colons instead of 1. Then comes whatever is there. If we notice CF, but each section has 4. This is hexadecimal. Therefore, I know that before that CF, there was a whole bunch of zeros up to there. And obviously, if I recall, this has 8 sections, right? 1, 2, 3, 4, 5, 6, 7, 8. Therefore, since I only have 1, 2, 3, 4, that means, and here goes 5, there's 3 sets of zeros in the middle. Loopback address is exactly what we see there. That's how we write loopback in 6. Questions? I hated version 6. I still do. Questions or doubts? There, if you notice, there is basically the default subnet mask is already 64 bits. There's no way of writing a subnet mask in here that I'm aware of in version 6. It uses just these numbers. As for the FEDC and other abbreviations that are used in the front, will allow us to know exactly what it's doing. Depending, obviously, if it's a FE80, this is usually a link local unicast address. You'll also see here your actual unique local address, which is the FC00 colon with a /7 or a /8. Those are the ones there. That's in reference to your
Can I get a pause
unicast
for a second,
address.
Diego?
Yes, please.
All right, we had an important question in the chat, and is where would you see version 6? Which is basically, it is the newest protocol. It's what we are all moving to.
That is correct. Version 6
IPv4.
is. Mhm.
Sorry, go ahead, Diego.
Yeah, go ahead. No, continue.
Okay.
Please.
IPv4, you had a maximum of 4 billion addresses. We started running out of those around 1996. We've been doing workarounds since then. IPv6, I think it's like 120 undecillion, which is 32 zeros. So each person on the planet can have like 64 billion devices with unique IP addresses. So we had to move to this protocol because we were running out of IPv4. Does that make
In
sense?
other words, they came up of a way to break up into more little pieces the world. So they created a much more bigger number to be able to uniquely identify any public IP address. Now, most of the companies are still internally using IP version 4. Majority of companies internally are still, but as for the internet, that I'm aware of, although you may have the equivalent of a IP version 4 IP address, it is an IP version 6 that I'm aware of that's being sent over the network. It's written
They
in
use
IP version
tunneling
6
stuff.
format. Correct. Your number can be translated. Your IP version number 4 can be translated to that number.
Dang, that's crazy.
Yes. So, my friends, you could try to figure out and hexadecimally try to go ahead and create the number back. What I do strongly recommend is understanding what hexadecimal number notations are capable. And we said it would be 0 through 9 and A through F. So if they give you anything that doesn't look anything like that, then obviously that's not it. And it must have eight different sets of 4 groups for IP version 6. And we learned that we could shorthand it. If there's a lot of zeros before it, we could just put the 2 colons to represent that everything in between wherever I started my notation to the end would be almost all zeros until I start writing the rest of the hexadecimal number.
If I could just add one thing, just from my experience with some tests, is that also another thing they might do is you might see an IP6 address with 2 sets of double colons, which is a dead giveaway. That's not a right address
That's
because
not
you can
valid.
only do that once.
That is correct. Good point to bring across. You could only do that once. In other words, if you see that it has 2 sets of colons all of a sudden trying to trick you, that's not a valid way of writing that address. That doesn't exist. So you would have to put the zeros. You'll see it here that it actually, where is it? Here he does it here. You see the 2 zeros here? So instead of the 2 zeros here, then you have the 4 zeros over here. You'll see that he put FEDC 2 colons, got rid of all the zeros, put CF. Now he put a colon, but he put a 0. And then he put a colon. Didn't put, again, the 2 sets of colons.
So that 1 0 right here represents
Represents the 4 zeros in that area right there.
Okay.
That's the only way they can shrink it again. So when they have a whole bunch of zeros in between after the first 4, they're gonna, a lot of times, since they haven't gotten to these higher addressing, a lot of these start with the zeros, because this over here, if you write it, it'll probably be a lower number, obviously. So they just shorthand it by writing it this way. Computer knows that I'm aware of also. No, it doesn't do that, does it? No, it does this. It does this and this notation, right? If I do IP config all, it gives me the shorthand version too, right? Never paid
I
attention.
think it just gives you the longhand. Let me check.
I just pulled it up on my computer and it is short.
Yeah, that's what I thought. Yeah, they do the shorthand writing too of it. Yep. Mine's a shorthand version of it too. It's got the 2 colon FE80, which I know that's valid right away. And then the 2 colons and then B971 and colons and everything else. Any questions? All right. So, my friends, as we stated here, the unicast packets themselves would be in this range here, depending if it's a global unicast, if it's a link local or a local address, that's the unicast address, sorry. And then the unique local addressing, which is these right here. Those are the type of unicast address. As for the multicast address packets, that's, again, the ones that get delivered across all nodes, and Anycast is the ones that are used by routers to identify multiple destination packets. I believe in the book and in the labs, they give you more details of those numbering schemes and how to read them correctly. We'll see you also here a little game that I like to always have. That, my friends, is this guy here. Now, can you see still my this thing or no?
Yeah, we can see it.
What's amazing thing is that apparently if she can do it, you should be able to create from hexadecimal into binary. She's able to look at the screen and it gives her the hexadecimal on the bottom right. And then she turns on the equivalent bits to be able to transfer it back. There it goes, sorry, AC. So then she creates that into binary and she kills the little bugs. My challenge to you, my friends, is hopefully that you at least deciphered on the keyboard would be that the first 4 bits is ZXCV, and then the next bits is B, N, M, and comma. So if I wanted to do 7, I should know that I should turn on everything from here, and that gives me 7. So like I said 1, 7. Where am I going? I don't want to go in here now. 7. Didn't want to turn on. One more try. So I want 6. So to be able to turn on 6, these are done by nibbles. So 6, it would be 2 and 4 equals 6. And 7, I said I turn on the first 3 on the right. I have my hexadecimal equivalent to binary. Again, 6 would be turning on the second bit and the 4th bit. E would be turning on the first 3. And here I am. 4 would be actually turning on, 4 and 6, 7 and A, echo and 0, A and 3, 9 and 4, 3 and Charlie. I can do this all day if you like. But you can see there is a little bit of fun when you start figuring out. Here are the letters, and if we look at the charts that we gave you, as you can see, these 4 represent the first number or the nibble of that hexadecimal, and the last 4 represents the second number of the hexadecimal. If we recall, 0 through 9 are themselves, and then obviously alpha means 11, 10, sorry. Bravo is 11, Charlie is 12, Delta is 13, Echo is 14, and Foxtrot is 15. And hopefully we remember that this is obviously, if I turn that guy on, that's 1. That's 2. So if I turn the 2 of them on, it's 3. If I just turn this guy on, it's 4. If I turn this guy and this guy, it's 5. 6 will be these 2. 7. I believe you guys have about 5 to 10 minutes to beat my score. My high score, although I only did 30 here, was 51, I believe. But good luck because they come flying at one point. Please enjoy. Seriously. Any questions on how to play the game? Questions, doubts on a hexadecimal and how to play the game? None? Everybody's a hexadecimal champion. So D, if I want to make D, I need to turn on this guy, and then this guy. Why? Because that, my friends, is D. If I want 1, it's only the first one. But obviously, since the 1 is back here, I would have to turn on this one over here. The first 4 represent the left number, and the last 4 represents the right number. So, as we learn, delta, if I turn on these 2, and the last one is delta, if I first turn on the first 3, that's echo. I want the number 2. That would be the second bit. I want the number 4 or 5, so I need to create 4 plus 1 is 5. Once again, I want 4, so that's the third bit. 5, we said, was the 4th and the first bit. That equals 5. 6 would be the 2 middle ones. 1 would be the first one on the right. 4 is the third one. E is turning on the first 3. F is turning everybody on. And then 7 will be turning on the first 3. Does everyone have the chart in their book and or labs? A little hexadecimal. Or remember that? Everyone just having too much fun.
I think we had it in a slide from the presentation yesterday.
So if we look at that Excel sheet of ANDing, it might help us at least get up to 15. If we look only at the first nibbles, first 4 nibbles, you'll see there that there is possibilities to getting onto and getting those numbers. Questions, doubts?
Yeah, the game will just take a little bit of practice.
Yeah. I can just remember B. There we go, B. It does take practice, obviously, because it just starts sticking to your head sooner or later. The more you repeat it. Oops, sorry, 6 and what I wanted 4. Oops.
Can you explain one more time? I think I didn't get it. I still confused. So which number is which?
Yeah.
Thanks.
Let's go back over here. Of course, you would do that. Oh, here we go. At least I have it down here. Okay. We learned that to write the number 0 earlier was me putting all zeros in, right? Remember me doing this earlier?
Mm-hmm.
If I turn everything off, it becomes 0. For now, just for the purpose of MAC addresses, forget about the last 4 bits. A MAC address and or a hexadecimal address only has 4 bits to represent each part of that number, because I could only go from 0 to F. So now I have 1. To be able to create 0, we said to turn them all off. To be able to create 1, I just need to turn on the first bit. Now I have the number 1. If I want to create the number 2, I need to just turn on the second bit. So I turn off this bit and only turn on this bit. Hence, 0, 0, 1, 0 is equal to 2.
Diego, you're not showing your desktop, so we only see.
Thank you, Diego. I want to thank you. You're very useful. Always, as always, you're great. Great.
When you
Great
were
in
pointing, we
sharing.
weren't seeing Flippy bit.
Can you see that now? Hopefully.
Yes.
All right. So in here, we can see that depending on what we turn on or off, it creates a significant specific number. Each one has its own binary representation. Because of me turning it on or off, it'll add those numbers. So we know that this is 0. If I just turn on the first one, it's 1. We said if I just turn on the second one, it's 2. So 2 plus 1 is equal to 3. So what's cute about this, it does this in sequence. Because of the fact that it does that in sequence, it's able to create any number at any given time. If you'll notice, if I know what the next bit is, then everything on before that bit will be the number right below me. What do you mean by that, Diego? Well, let's see. We said if I turn everything off, it's 0, right? So if I turn 1 on, then it's 1, right? But look at what happens because it's 1 less than the next bit. But now the next bit is 2. If I turn everything on before the next bit is equal to 4. It's equal to 3. If I turn these 3 on, the next bit, the last bit, is equal to 8. But if I first turn on these 3, it's equal to 7. So any given combination of me turning on and off gives me the variances in between these bits, because 4 plus 1 is equal to 5. 4 plus 2 is equal to 6. 4 plus 2 plus 1 is equal to 7. Now that he got to 9, the next number is 10. What is 10? 8 plus 2. because the last bit here is 8 plus the second bit, which is equal to 2, is 10. Then I just add one more. That's 11.
One thing that helped me was just remember that A is 10.
A is 10. If you can remember that A is 10, that is the most helpful thing you can do. And F is 15. So that if you ever mess up and you didn't get to 15 correctly, at least you remembered A was 10 and 15. You could try to figure out which one is which after that.
I got you. I got you. Thank you, man.
Okay, not a problem. But to me, by this point, believe it or not, I do not change it. I am able to change from hexadecimal to binary. I don't translate to base 10 first. I'm able to, I memorize this week, and that flippy bit will get your brain getting real quick. You will find out that you could actually translate from, and which is scary, you'll be able to translate from hexadecimal to binary 10 times faster than base 10 to binary. I'm willing to bet 10 bucks on that one. Of how easy it is to actually your brain get accustomed to this little code right here.
Diego, is that example at the bottom using the base 10 first? Right under the chart, it says example, convert 6C base 16.
6C. So they're giving you 6C. So if you got 6C, how do I write 6? What in the world is he doing now? You got me all confused. That's a good one. 16C hexadecimal to binary. Yeah, so 6C. So how do I write the number 6?
0, 1, 1, 0.
Correct. They missed a 0 if you can see here.
Okay, that's what was
confusing
me.
Okay. Sometimes they like to mess around with people, and just like in base 10, they like removing the zeros. In other words, if I have $1, I'm not going to give you all the zeros in front of that dollar, right? It's infinitely going to the left, those zeros. Therefore, again, IT, we're lazy. We love shorthanding everything. And in this case, they only give you 7 of the bits, not all 8, which means that the leading zeros is there. Good call. Any other question? Does this make it a little bit easier to understand the mayhem of how to read a hexadecimal and translate the number to binary? Because then from binary, you'll be able to transfer that number to a actual physical number. Right? No, maybe so. Now, can anybody understand that if I write FF, Y equals 255? Someone please humor me. Why would FF equal 255?
15 times 15? No, that's not right.
Well, you're close. You're so close. Remember, I'm giving you a
16
nibble.
times 16, even though it's
It's a nibble and a nibble. You see it here? Here's your F because it's 1, 1, 1, right? That's your first F. And here goes your second F.
Oh, okay, it's the total value of all
The
of them.
total value of 8 bits together is equal to 255.
Right, that's the 128 plus the 64 plus 32 plus the 16 plus the 842.
Yeah, all of them together, correct. And why I know it's 255 right like this, because if I remember, binary goes, we said 0, right? 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. So since I said 256, I can stop there. If I turn everything on, and Diego said it's mayhem, before I get to 256, if I turn everything on and I don't turn on 256, 255. The next bit is 256. Question? So that, my friends, is how you could write 255 shorthand by putting FF or any other number that you would like. Now you understand how IP version 6 translates to binary back to decimal. But no one goes through that much trouble unless if you really want it. That's a big number, right? So you don't want to mess around with that. It just take you all day to try to write that number. Hence why they're writing it in hexadecimal. Any other questions or doubts? I guess we can continue. That's not it. This is the guy here. So how do we obtain an IP address? Am I still showing my screen? God only knows. Yes, supposedly. Is that correct? I take that silence for yes. As we stated a moment ago, the DHCP server himself assigns an automatic address of available pool addresses. You actually configure the server saying, hey, from this range to this range, I want you to automatically assign these addresses. Now, anything that's not on that list is considered a static IP address in my network, who I can now give and hopefully keep track of. You should be keeping track of. That's why change management and documentation is must in these companies, because now every static IP should have a reservation that you don't go and use it again. Once again, these are put into change management and keep track of whatever that printer is, who that server is, or whatever static IP. As for the DHCP server, he can really care less, but he knows that he can't assign those technically. So those are considered static IP, manually assigned IP addresses. If the server itself fails and or the actual router is unable to reach the actual DHCP server, then a people will automatically assign you an IP address. We need to fully understand that human errors will apply, and that's why the computer will scream out whenever some IP is duplicated in the LAN. He will let you know, and basically no one that has that exact same IP address will be able to talk, because this unroutable now that I have two places to go, it drops. It will not send the packet, and you will know because your computer will be letting you know that your IP is twice on this given network. Questions, doubts?
With the idea of a duplicate IP, does it just kick out the second person that tried using that IP, or is it going to ignore both?
Both. Both will go down. That's one quick way of taking down a server, if you like. Statically put your IP as him, and he won't be able to communicate because of the fact that it's unroutable at that point. There's two locations that I need to go, and I can only go one. So that's why the operating system will scream and show a message stating that this problem exists on the network. Unfortunately, it only screams it to those two computers. Therefore, let's say I do that to a printer and then I put that on another printer, I'm not getting any messages. I don't even know what's going on because of the fact that I don't have an operating system that's going to tell me that this printer has a duplicate IP address and that printer has a duplicate IP address. It's very dangerous when we're playing with static IP addresses, hence why we must document everything on a network that's statically assigned. Questions, doubts? Alrighty then. Next here for the actual Windows, you'll see that it has a little GUI to be able to go into it. And my friends, where is he? Network settings, properties. This now. Just a second. I always forget. I think mine, since it's home, it stops me from doing things. It's really annoying. It hides it in a different spot because God only knows I got nothing better to do. Finally. So before I got here, let me get back out. Sorry. Can you still see my desktop?
Yep.
Okay. So I went to go look at the actual device that's actually here. I can come into that device, which is my actual Wi-Fi, right? Hit properties. Inside the properties of this given device, I can check and configure the actual TCP/IP version 4 settings. I can leave it with obtaining it automatically, or I can specify it myself. Specifically, anything in here, I can manually enter the information. Now, I could also leave it to obtain IP addresses automatically. And let's say maybe I know that I always go into maybe a certain facility or somewhere, maybe my house, I want it to be slick, and I only created to allow static IP addresses. So to be able to allow you to just keep the first configuration of allowing you to automatically have an IP address, it'll do that. But instead of giving you an APIPA address, if you configure a manual IP address, it will actually do that in this tab. Whenever it fails, it will actually have that alternate IP address to be able to configure and use. Questions, doubts? And here we see our IP addresses, which is our address, the subnet mask, which is obviously what we mentioned before, the one that actually divides the network into pieces. The next section we have here is the actual default gateway. The default gateway is my way of saying, hey, if nobody here answers, this is where I want you to send it. Send it to him. And that, my friends, is why yesterday when we saw that if the MAC address couldn't be found, my answer would be to that switch at that point. Since I gave him my default gateway, send it to him. Let Mikey do it. Next area here is for my DNS server, which is the domain name server, to allow me to be able to resolve names into IP addresses. As we said earlier, it only sees zeros and ones, and it can only see IP addresses. Therefore, I need to be able to answer what's the FQDN, the fully qualified domain name of this computer, to an IP address. Next, also, Windows has its Win servers to be able to also help facilitate it in its domain within the Active Directory for the intranet. Questions or doubts? I usually get scared when I hear crickets. All right. So we'll go back over here. As we saw and alluded to earlier, if I go to a given device, any device, I should be able to then look at that network's device, go into its properties, and configure the IP version settings manually if I wish to, depending on how I set it up. Obviously, now that we know what are our default subnet masks, we should at least be able to create those default subnet masks correctly and assign static IP addresses as necessary. Any questions?
So that would be that would be for a personal system, or is that you working for a company and you have a list of static ones that you own and you're just switching them around?
Yeah, that would be, this would happen a lot when it comes to servers, printers, any device that you want to make sure that always it has the same number, because of the fact that if your number changes, now I can't get to you.
Mhm.
If your number changes, I can't get to you.
Where
Do
did
you
the
understand?
192.168.1.1 come from?
This is just an example. So they're using a class C addressing. They're saying that their router is 1, so the router would be able to answer, and apparently there's another device that's able to answer. Those are the two devices on the network that are able to change names to IPs. Any other questions before we hit next, please? Now, where would I get static IPs? In all Fortune 500 companies, there is a internal application where they track all static IPs to ensure that we use the correct, and they even have set policies and procedures to say who can use what. They will actually use a range of saying, okay, routers can use this range, servers can use this range, printers can use this range, applications can use this range, specifically stating inside a current subnet which ones are available. Obviously, depending on the size of the company, some of them just don't care and maybe have an Excel sheet if it is small, like a mom and pop, just to be able to keep track of all static IPs. Questions, doubts? So anything that I want to manage, anything that I want to make sure that it's always keeping the exact same address because it's providing a service on the network requires a static IP address. I fully understand, yes, printers and other devices will work fine, but if inside a company, we must be organized, and these type of devices that we're using must have static IPs so that if something happens to the DNS server, I can get to the device. Maybe
And
that
so
may
we-
help everyone why a static IP exists. Because if you could just imagine, if my router address changes because the DHCP server gave it a new IP, how am I going to get to that router?
Right. So that
So
particular
therefore,
company will get their static IP addresses from their IP provider, the internet provider.
the private IPs would be managed by the internal IT. They must manage it themselves. All private IP must be managed by the company themselves. You decide what's static and what's not. The DHCP server leases out all automatic IPs. Therefore, anything that's not in that lease environment is considered in the range of static because the server is not going to give anything in that range.
Okay. But every company gets their own specific static IP address, or does each individual
Public IP address, yes. Public, yes. Every
Okay.
company has a public IP address. Now, the router, if you're looking at Xfinity or something like that, and it's not a circuit that's going straight out to the internet. In other words, you didn't buy a public IP address, you're just leasing one.
Yeah.
That's a different thing. There, your IP address may change. Hence, you'll see a lot of companies start purchasing static IP address for DSLs and for any type of environment when they're trying to create a VPN with certain rules, because now they got to know what's that static IP in the internet to be able to open that tunnel if they want to be that hardcore and make sure that the right people are coming in. Once again, depending if you want public or private is your choice. All ISPs have a set range that they can lease to you. Since you're already paying for the service, they're going to assign automatically out of their humongous pool of available IPs an IP to you. And since they're living now in version 6, they're able to play around with that number even bigger, obviously. They're not stuck or confined to version 4.
And there's no such thing as a version 5.
Yeah, no, but it would be kind of great if they would actually go in numerical order. If you would think, right? Version 4, okay, there's 4 octets. Okay, version 6, there's 6 octets. No, there's 8.
It probably was, but it was only experimental,
Oh, okay.
and they never went full public with it.
Wonder who creates these addresses.
Who? What?
Like,
How?
as
IP,
far as IP addresses. like-
IANA is the ones that reserves it. Remember?
oh yeah. But there's no physical person that's actually putting in information to create IP addresses. It's more so in the actual internet itself, or through the system itself.
I'm sorry, it broke up on my point here. Give me one
Okay.
second. If you could repeat the question, I just turned on now the boost. It looks like
What
my
I was
PC
saying
is
is there's
logging.
no, I'm sorry, there's no physical person that or people that are part of a company that actually created IP addresses. It's more so just pulled out of thin air in a sense.
IP addresses were created by the DoD, and IANA is controlling them.
Okay,
Department of Defense.
those guys.
That's why whenever you think when you're on the internet that the government is not included, hence Cuba, Venezuela, and all these countries, they're as obvious as they can be because they are in full control. You can thank the United States that supposedly this is a free country, but good luck because all of that is still under their control.
Yeah.
Internet is the wild, wild west because every given router that's on the internet is able to communicate with each other. Hence why the dark net it actually exists.
Yeah.
Questions?
That's some spooky shit you just kind of threw out there, but yeah.
One question.
So,
So if I hook up a device to the network that has a default IP
Mhm.
and it's given a new IP by the server, does that mean the old default one just goes away?
the default gateway, you're saying?
No,
Yeah.
if I'm like, if it has a default IP address.
If you have an automatic IP address.
Yeah.
Okay. If you have an automatic IP address, the DHCP server will give you the new one if necessary. It takes time for the DNS server to obtain the latest and greatest, unless if you went and flushed the DNS server with the information. Hence why static IP addresses are there to avoid this, because if the server's IP address changes, it takes time for it to replicate over the network so that all DNS servers know what that new IP is.
Okay.
So usually anything that's providing a service and or you need to be able to get to remotely for with ease, obviously, and to assure that you know that that should be the machine, you would assign a static IP address to. Or you want to lock down your network, completely shut off the DHCP server and manually assign static IPs to everyone. That way, unless if you know what subnet is on the network, there's no way they'll be able to talk to each other. Everyone wouldn't be able to talk unless if you manually set an IP. Questions, doubts?
One more question. So if I have a device that's assigned a version 4 IP address and I want to access it outside the network, is it automatically assigned a version 6 or is it converted to a version 6 or?
That, my friend, is called NAT, or
Okay.
I believe they also call it PAT. Is it PAT? NAT? Yeah, public address translation. What happens, see, is when you leave the building, as I told you, private IPs are not routable. So what happens is the router represents you in the internet. At the time that you request something, he himself now acts like if he wants that information. He grabs a table and keeps track of what you want, and he assigns you a specific port. Now that he knows what you want, he removes your private IP and he puts his IP with the port that he just assigned to you. He gave you a number, so that would be like your mailbox, so that I know where exactly to go back to this original conversation, because you could be having several conversations at the same time. Now that I know where this is going, I send it out with me as the router asking for that information with my public IP address and the port that I just said that you were on. The other side answers and gives me the information. I strip my IP, which is called, again, PAT or NAT, depending which way you're looking at it. Network address translation is the same as PAT, but PAT just means that it's public address translation to actual local address translation. And he changes the number once again and gives it back to you, obviously to the switch, who then passes it on to you.
Thank
That's
you.
ugly, real ugly quick when we start digging into this guy. But it is interesting, and that's why the default gateway is there. That's who is going to be your representative in the internet, and that's his address on my network. But that's not his WIC card. That is his NIC card, but that's not his WIC card. As I said, a NIC card is the network interface card for the LAN. The WIC card is the WAN interface card for the WAN, wide area network. Be that it is the intranet or the internet, depending where your WAN circuit takes you. Questions? All right. As we mentioned a moment ago, the gateway is the router that allows you to be able to get beyond your neighborhood. He is your mailman. He's the one that's able to get everything out of this building. So you just basically drop it in that little box to him, and he then translates your private IP to the public address and communicates over the internet using NAT, which is the network address translation, and a fancy way of saying that he has a big table keeping track of all the conversations that are going on, and he uses his IP to represent everybody in the neighborhood. As soon as it gets back to him, he's able to then strip his IP and put back your IP and sends it into the switch. The switch then obviously routes it to the correct by its actual MAC address. As we mentioned, everything gets encapsulated. Remember that encapsulation of all that information. So with that information, it knows then where in the network this PC is, which is the MAC address. Questions?
Yeah, can you give us an example?
Of the gateway?
Mm-hmm.
Okay. We can see here. Let me go and look just for the small version of this information. We'll here see that the IP version 4, and here is my IP version 6 of the same guy, because I have both of them turned on right now, and it will assign both of them in your local network. You could actually turn it off in the card physically if you don't want version 6. It's the exact same number that you see here would be represented as what's here. Now, here's my default gateway. He is the guy that that gets me out to the world. That is the address that in this building gets me out. If I, where is it that I,
So like
I
an
think I have
exit.
that is the door to get out of the building.
Yeah.
Yes, to get out of this building. Now that I got to him, he knows by the number that I want to get to if it should leave the building or not, and if he can route it or not by that number. Depending on that number and where it is, it then routes it to the appropriate routers. It sends it by replacing this number with a public IP. And how do I know that? You'll see now that if I come in here and I ask, what is my IP? I believe it's as simple as that. Here's my public IP address. This is my router's IP. That's his number. And so what he does is he strips away that number that I have and he gives the world his address. He sends it out to that area over there. Since DNS all web servers are on the internet. They have a public IP.
Right.
Now that I got to that place, that router in that network, he routes it to the appropriate IP.
Gotcha. And so this is without using a VPN.
Correct. There's nothing
Okay.
to do with VPN. Correct. Any questions on natting?
Ron,
Or how
you
to what?
you don't have any questions?
Not at the moment, no.
Alvarez, Chris?
You could always think of him as your senator representing you for your country or state or whatever you want to call it. He is the one that's talking to you for the world. He represents you to the world.
Gotcha.
Any other questions or doubts?
David, any questions?
Nope.
Okay, fully qualified domain name, which is the FQDNs. As we mentioned before, all FQDNs are able to be changed into a physical IP. So if we ask the domain name server to resolve this, it will give me the equivalent number so that I can be able to send that information over the network. Because the FQDN is only the friendly name for us humans. As we stated, the only way I can talk is over IP. All DNS servers and domains trust each other, which is the most dangerous reason and the major reason why they're extremely locked down. If you are able to get into a DNS server, it will fully trust you as an administrator of that. You will be able to create damage, which would they call that DNS poisoning, and giving false entries into this database and resolving obviously the IP to someone else. That's how dangerous these things are. They're full trust to each other.
So this is
If a
basically
DNS server says that the IP address is this, everybody says, all right, let me pencil that in. I'm sorry, someone had a question?
no, I was saying, so this is basically sounds like that in a sense you sound like this is hacking.
A domain name server, his job is to trust him and any other domain name server to be able to facilitate to talk to .com, to .org, to .tv, to .co, to .cr, to .ca, any of those different countries and or networks that we're trying to get to requires that all DNS servers trust each other to be able to facilitate the process of updating the internet with the IP addresses. There has to be that full trust to be able to facilitate that process. Otherwise, imagine asking every single time to update all these numbers that keep on changing. Any questions, doubts? All right. As we mentioned them several times already, binary to decimal is a base 2. So as we stated, the first 8 bits are equivalent to those numbers. If I turn it on, it's 1. If I turn this one on, it's 2. And that's because of the value of that bit. And since it is binary, 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. And so forth. 2 to the 7th is 128. With 8 bits, as we said, there is 256 combinations because we include from 0 to 255. So technically 0 is a number, and that means that there's 256 capable combinations.
Okay, that makes much more sense because I was wondering where you were always getting 256 if it only ran to 255. But like you said, 0 is now considered a number when speaking in binary.
0 is always a number that exists for computers. It always exists.
Yeah.
Especially in programming too. zero is a value is a valid number. It's a start for an array, for tables sometimes, depending which programming you're using. So as we see here, depending which bits we can turn on, it will equal whatever number from 0 all the way up to 255. In this case, they only turned on this bit, this one, and these other two. So if I add 128, 16, 4, and 2, that equals 155. And that's what, sorry, 150. And that's how you represent in binary the decimal number 150. So if we're looking at the decimal here, right? This is 150. This is human. And if I break this guy apart, can somebody tell me how to convert that to hexadecimal? What's 001? What is his number in hexadecimal?
9.
What's 0110?
6.
6. So if I write the number 96 in hexadecimal, that equals 150. Interesting. Yeah.
Yeah, that's interesting.
I mean,
So this is the human way of reading it, the way we're used to reading it. This is the hexadecimal way of writing. And this is the binary, what it really gets sent across.
you know it's hard when algorithms get quiet. Oh man, do y'all really understand this? Because I don't. I'm gonna be honest with you. I mean,
It's new to me, but I'm trying to follow.
I understand pretty much what he's saying. I just got to put it in terms that I can understand to make it easier for myself. That's just going to take me to study. That's all.
Yeah.
And repetition
Mm-hmm.
around switching from binary to hexadecimal.
The video, the little game, that
Yeah.
game is very helpful, man. I
Yeah.
assure you, you'll be surprised how easy it's going to get for you to be able to convert hexadecimal to binary. It'll be the most easiest thing in the world to do. Now,
And it's only 15 numbers.
from regular decimal to binary is a pain in the butt. But from hexadecimal to binary, it's very easy.
Yeah. And it's only 15 numbers because binary can
Exactly.
go infinitely out. We're only doing the
Exactly. Exactly.
We're only doing the first 15. So
Mm-hmm.
yeah, because man, David, our #1 test taker, you good?
Yeah, I
Right.
already did a lot of this, so this is kind of review for me.
Well, wait. Okay, so you've done this before.
Yeah, in a networking class last summer.
Really? Is there an easy
Also,
way
you've
of training
seen
this?
I posted some stuff in Slack, some videos that I've used in class and some other things online. It helps just to kind of keep reviewing it and like looking at it from different angles. Eventually it does make a lot more sense, but just it takes some time to process. So don't feel bad that you don't get it right away. I didn't get it right away either.
yeah, this isn't something to get right away on the first rip. You got to get into it and break it down to where you understand it.
Yeah.
Yeah, I mean, everybody is able to understand it their own way. You know, in my class, everybody hated me because since math to me is too logical and it's too simple. The first day that networking came out, everybody was there and I missed that class. And literally the teacher just basically told me what the bits were and what their values was and how to write it. And I said, okay. And everybody called me a liar. Then again, it's for me, my mind is too logical. I'm not kidding. And unfortunately, God has given me that gift that basically in math class, I would always fall asleep homework was already completed and classwork was done, and she was still teaching calculus to everybody else in class. So it's all unfortunate, without you repeating it and learning these binary values, this part of the chart is the most important part. Memorizing those numbers and what they mean makes it much easier, and practicing that little video game makes it much easier for you to convert hexadecimal to binary. Repetition is your friend in this case. The more you repeat it, as I said, different videos, watch different sources, and eventually you're going to have that aha moment, and then you're going to go back to the other videos. You're going to go, that's what they meant when they were saying that. Or you might just want to kill me by the end of this whole program. That's about it.
Alimu, are you okay?
All right. So, needle pulling thread here.
Trying
Let's
to hang
continue to
up.
try to.
Said it
I'm
again?
sorry?
I'm trying to get it.
Oh, you're trying to, okay.
It's a bit hard.
Yeah.
That's really hard, but
Oh, yeah. Mohammed, you good?
Don't ask me, man. I just, my mind is fighting each other. What's going on? I just try to take records and search about that and look for that.
We have the test out videos and labs in there. They will do their best. We also have the crosswalk documents with Professor Messer's videos. And I believe we also put in the chat some other videos there. Every day after class, if you wish to continue this type of conversation, we are here to continue this. This is not just for today. Trust me, networking is not a one-day event. This session and yesterday's session used to be bundled into one day, which was always cute, trying to see everybody's face, trying to understand everything. But your TAs were nice and decided to split it up into 2 days.
Right.
Thank you.
Thank you, guys.
Now, as we mentioned earlier, TCP versus UDP. As we see, TCP is the one that's connection-oriented protocol. In other words, it checks whether you received it or not, and it's able to reassemble it because each packet has a specific number sequence. Each packet has its number sequence. So he'll know which is part 1, which is part 2. Now I got part 5. I got part 4. Well, what happened to part 3? Anybody see part 3? No? All right, time's up. Send me part 3, please. That's how good he is. He automatically will go and request because he's trying to put Humpty Dumpty back again, but he seems to be missing an eye. And since he's missing that part of the puzzle, he will ask for it. As for UDP, this is when you're what they call connectionless. And obviously it's good when we consider broadcasting and streaming, because just imagine when we have lag, if we're trying to wait for the video and the voice to get there at the same time and to put it back together, it will be very, very consuming. And at the same time, it wouldn't have that feeling of an actual conversation as we're used to on a telephone. So it will do its best to maybe fast forward the video. You'll see it all of a sudden. It starts running through the things, but you were hearing me talking, and it looked like you were just watching some type of Chinese translated movie from the Kung Fu days. Questions or doubts? So UDP can care less. He just keeps on sending it. If it gets there or not, it gets there. So what happens there, if it gets there too late, he can care less. That got nothing to do with me. That's too late. Get out of here. I'm already gone with this information. Questions?
Diego, on the previous slide, it mentioned a handout. Is that in Canvas, do you know?
There should be a handout in Canvas, or we might have a Google form for you guys to be able to practice, which will do the several octets and the numbering scheme. Yes, you are correct.
Ronald asked, are we talking about packets being sent?
I'm sorry.
Oh, never mind. Kelly said correct. I was saying, Ronald was asking a question in Slack.
Yeah, it's when transmitting
I mean,
information,
Chat.
Packets, they're called packets.
TCP is going to verify on the other end. Hey, did you get this? UDP doesn't care. It's just going to keep sending.
So what happens is that TCP, they have an acknowledgement. So what it says is, hey, you, are you there? I want to start talking. He says, yes, I am here. What would you like to talk about? So then he says, okay, let's start talking. Tunnel is up. As soon as that TCP tunnel is up or that session is up, at that moment, until that call is released, it's just as going ring, 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 ring. Hello, who's there? Now, not until you actually end the call do you say, hey, goodbye, see you later. Now you know on the other end, don't expect anything. Let's close this call. There's nothing to do. UDP only sends, doesn't confirm. He does create the UDP session itself, but he's just transmitting and sending. Never asks if anything ever got there. No matter of fact, he can care less if it's irritating the living daylights out of you or if it's in order or not. He just doesn't care. He's just sending it at the best effort. If there was happens to be that there's a broken down bus in the way, or maybe the paper got there late, whatever it is, he can care less. He would just ignore that packet because it got nothing to do with what I'm talking about right now. Best effort protocol, connectionless, because of the fact that he doesn't ensure that communication is stable and up, and that everything is getting there, and that I'll put it all back together. Questions? So as we stated, TCP is as good as getting a UPS package where you need to sign it off, where you need to confirm that everything is okay. A UDP would be as the old post office where you put a nice little stamp on it and you only hope that it got there.
Here's to hoping, huh?
Yeah. No confirmation, no way that they're both saying, okay, see you later, none of that stuff. Network sockets. All right, for network software component used to connect the LAN or WAN, but can also be used to connect within the computer itself. The sockets are the ports. That is what the socket is. As we mentioned, when we put the actual IP, and now the way to represent it is the colon and the port. So the port 25, for those that studied already, SMTP is my sending port. That's how I'm able to tell that IP address what application I want to use on you. What's the service that I need from you? Next one down is, again, the IP address and the port. And for those that may remember who port 80 is, that's HTTP. All servers have services that are either turned on or off. If this server does not have port 80, it will not respond with a website. It will not give you any information. So in other words, to lock down these things, we make sure that certain ports are closed. If it's not a service that we are providing, they must be locked down. Once again, an open port means I have my window open. If I have my window open and you know my address, you can just jump into this window because the port is open. Means that I'm open for business. I am providing websites, or I am allowing you to download emails or send emails. Sorry, that's 25. Questions or doubts?
Yeah, you got to keep those ports closed, otherwise you can get hacked.
Oh, yeah. Questions, doubts? So now we said the first part was the IP. I'm able to route it because I know exactly what is your network address, and I found out where you are. But now that I know where you are, I got to your door, I'm knocking on your door. Where in your house do I want to go? That's what that port means. Is it in your living room? Is it going to your kitchen? Where is it that you want to go inside your house when it is your physical address? That port represents a house inside your computer. Sorry, a room inside your computer, a spot. That application will answer if it exists and the port is open. Otherwise, it's not going to answer. Questions? So this is what it looks like when HTTP passes it to IP and he adds it. When I first come into HTTP, I only added the port 80 and because of the TCP session. And then here I added the actual IP of where I wanted to go when it got to the IP area. Making sense now? Then the packet, I know it looks weird because it starts encapsulating. So it looks like maybe that little, you ever get a package where somebody tries to be cute and they wrap a package inside a package, inside a package, inside a package, inside a package. And then when you went go as a little tiny thing, you might have did it to your girlfriend and gave her a ring or something. I did that once. But either which way, it's kind of funny just to look at their name at them doing it. But this is what it's doing. To be able to keep track of every part of what it pertains to it, it encapsulated with its information, and it has a payload, which is the actual information that it wants. The payload is what you're asking for. Everybody adds their part to be able to keep track of the mayhem. Port 80 is the application saying which one I want. IP tells me where I'm going. MAC address says where I am in the building. And then now my NIC card will send this out in Ethernet language, similar to a Morse code, interpreting all this information out to the world. Remember, if I wanted it inside my computer on my hard drive, there's no necessity to go and encapsulate and or do anything because now I could just go straight to my hard drive. This is to help make a call, similar to a phone call. You're doing a network call to someone else. Questions?
Would we ever get a question asked about what port 80 would be?
Oh yeah, you need to know what port 80 is. HTTP.
It won't be that specific though.
What they might throw to you is that there's problems with maybe getting on to websites, but they can get into secure websites. Now, what's the problem on the network, for instance? They're not going to ask you what port 80 is, but you need to know what it is to be able to identify that if they're able to get to secure sites, that means that port 443 is on the firewall, but unfortunately port 80 seems to be blocked.
Yeah. Or you need to set up email. What ports do you need to open up to set up email? You know, they would do something along those lines.
Mm-hmm. Because of the fact that you must know how to configure a firewall and what it is. And since you need to be able to troubleshoot a firewall, you need to know the most used ports, the most famous used ports, because it gets even more tedious when you get to Network Plus. They add more ports that you need to know, and security ports adds more ports also that you need to memorize, which are all ports, well-known ports that are already defined for a given application.
What?
For almost anything you want to do via communication, there is a specific port you would need to access. If you wanted to do a file transfer, you would use your file transfer protocol, you know, and then you want to secure it, you could use secure shell. If you wanted to send mail, you would use SMTP. If you want to send mail, if you wanted to receive mail, you would use POP or IMAP. You know, so depending on what you're doing would determine which ports you needed to open. So understanding what those ports are, you know, what you use them for, is very important for the common ports. I think there's just about, I think it's 12 or
I think they're going to
14
show us
ports that you
soon.
need to know for your
Yeah.
bus. Yeah.
They're going to show us here, and in test out, they also go over the specific ports
Okay.
that you're going to be tested on. So the TCP and well-known ports for communication, as we said, each one, it has either TCP or UDP services, depending obviously on what you want to do. If you want a guarantee, it's going to have TCP. If there's no need for guarantee, then it's going to be sent using UDP with its appropriate actual number. Questions or doubts? One way of also knowing one easy way of knowing if it does use TCP or not, usually if it needs to answer you back or if it needs to authenticate, it must be TCP. Usually, if it needs to answer you back, is the most common way of remembering. It needs to be secure and or answer back and confirm is usually TCP. UDP doesn't care, so he just continues to send. And we'll see what that means soon when we review each one and what they use for. As for your TCP ports, common ones, you have your FTP. FTP uses port 20 and 21. Those are the well-known ports that are reserved for it. So anything that wants to do a file transfer would be using FTP in clear. That is clear text. Clear text means that if I'm sniffing the network, I can actually see what's going on in the network and I can read it because it's in plain text. Next port, if I really wanted to secure something, then I use SSH to be able to use that to pass it through an encrypted, using SSH, which encrypts the actual traffic and obviously facilitates ensuring that it's not in the clear. If I wanted to remotely connect to another device in the clear, I would use Telnet, which is 23. If I want to send an emails, which is a simple mail transfer protocol, then it's port 25. If I wanted to get from that computer a DNS entry, then I will be sending that information to port 53. As we saw inside my TCP IP settings, be that it is on auto or if I manually, when I set it to auto, the actual DHCP server gives me my gateway and gives me my DNS servers. Hence, when I go and ask for a name, I already know what's the IP of that server. So I send to that server's IP address the name that I'm looking for on port 53. I put the IP address, port 53, and I ask them the question, who is so-and-so? I want to send an email. So I know what the FQDN is for that email server. The DNS server just gave me the IP address. I grab the IP address, I put port 25, and I start sending my email out. The email server will send it out to the appropriate domain out in the internet. If it's its own internal email, obviously it won't send it out. It'll just send it to whoever it is internal in that domain. If it's external, it forwards it to the external domain who will answer. Questions or doubts on ports?
You can use these, and I'm asking you this, can you use these different ports by accessing through your command prompt, I want to say? If I think that's the name of it. It's, yeah, your command prompt. But I'm not sure how to actually access.
With terminals, you can access certain ports specifically directly through there, but depending obviously on the application itself and how it's locked down, you might not be able to go directly through that port. But it is a vulnerability, that a window that's open, that if you are smart enough, you can hack it eventually, because that port is open, it's listening, it's Windows open, it's waiting for a communication. That's why they should be locked down with passwords and hopefully getting, maintained and updated with all types of security features, Windows Defender, whatever it is, to try to keep these things secure. Hence why we should be putting these servers in a DMZ zone, because since they are vulnerable and those ports are open, we want to make sure that if something happens to him, it doesn't go into the actual LAN.
Right. Right. Okay. Ronald, do you understand? Or you have a question?
All right. So if I had a network where I wanted people to access like a company email, I would go ahead and turn on port 25.
If I want them to be able to send emails, I would have to make sure that the firewall allows port 25 to get through and that that service is turned on, the service where the port is turned on. So the server has to have the port on, listening, open port, and obviously my firewall has to allow it to go through.
Okay. All right.
The firewall has a set of rules that say what's allowed to be done or not in the network. That's one way to secure your network with a firewall. More ports to learn. As we mentioned earlier, HTTP, which is the Hypertext Transfer Protocol, that one's the one that governs the actual websites. That is in the clear. If I wanted to actually send it in secure or encrypted messages, that would be port 443, which is HTTPS. If I want to be able to receive an email, there is two ways. There's also Exchange, but the common ones here, which are these ports here, is, and we need to learn, is POP and IMAP. Variance between POP and IMAP is very small. POP downloads the information and deletes it from the server. So as soon as I download the emails, it's gone. If something happens and I happen to delete it from here, it's gone. IMAP, you're able to actually sync and it leaves the copy on the server. So if I download it to this unit, but then I go and I log on to that computer and I want to look at and download it in Outlook, it will always have a copy on the actual server itself, unless if I delete it from the server. Questions on either POP or IMAP?
Jose,
That's
any
how
questions?
I download emails.
Different companies use POP3 or IMAP. I don't know if they use both. I think Cox Cable down here uses POP3, and AT&T used IMAP, if I'm not mistaken. So they
It's all
use,
depending on how they want it.
yeah.
It's your choice on how you want to set up that email server. What's I always find very interesting is that there's SMTP is the port to send, but then to receive, you have either POP3 or IMAP. And the reason I remember 110 is because I've just beaten it all over my head. But IMAP looks just like the old texting of I love you, which is 143. For those that remember how to text in the old beepers back in the day, 143 means I, which is the number 1. 4, which is LOVE, and U, which is YOU, is the 3. And that's how I'm able to remember IMAP. All these things require repetition and playing with them and coming up with some way of remembering it. Now, my friends, RDP was a Windows way of, or is a way of connecting, which is 3389. That's the port for remote desktop. And since I know that Microsoft also has the LDAP, which is the one to be able to resolve for emails, your addresses, phone numbers, and all that stuff, my friends, that means 389 must be LDAP. 3389 is the bigger number. And since R is after L, that means L is smaller. So 389 is LDAP and RDP is the bigger one. So you put another 3 in front and you got 3389. I know
Is that
I'm
how
crazy.
you remember
Can I tell
stuff?
you? That's the only
Yeah.
way I can, man. You want to see how I remember which one is the private for B?
Yeah.
Because I remember that I'm part dyslexic. Since I remember what 127.0.0.1 is the capabilities of having a loopback address. So since my dyslexia kicks in, I can now shuffle those numbers around. that means that 172.16.0.0 is the private B address. Everybody comes up with their own game on how to get there.
We have a mnemonic that we'll give you guys that'll kind of help you remember the order, like in ascending order, and which, you know, all the ports you'll need to remember. So we'll get with you guys later and give you guys a mnemonic to help.
Mm-hmm.
Perfect.
AF. Mm-hmm.
Wait.
Go ahead.
Oh, cool. About the remote desktop protocol, though, isn't that something that TeamViewer uses as well, as far as that port goes? 389. I mean, because technically you are tapping into someone's computer remotely.
I would have to see which 59, supposedly 5938. That's the reserve port.
Oh, okay.
They have their own. RDP is Microsoft's port.
Gotcha.
AFP, if I want to be able to do Apple File Protocol, is port 548. Obviously, those will be for the actual Apple computers. DHCP, as we mentioned before, is for Dynamic Host Control Configuration Protocol, which facilitates the process of addressing IP addresses to everyone that wants to lease an address automatically. DNS, as we said, is the domain name system for messaging protocols, which allows you to query the database and it responds with the information, and the latest updates are replicated throughout the whole farm. All DNS servers are talking always to each other and updating each other. LDAP is the lightweight directory access protocol, which I stated a moment ago. And since it is used to be able to facilitate the directories, this is the LDAP is where you usually go into Outlook and you want to look up Pepe's phone number and he's in your company. That's the LDAP that you're using. That lightweight directory access protocol allows you to query that server and be able to go ahead and look for his phone number or his address or whatever is on that database itself. SNMP is the protocol that's used for network management. It's the actual server network management protocol, which allows all devices to be able to talk to each other. SMB, which was my favorite, was where the blaster worm had fun. That's with the server messaging block. That's what Microsoft's protocol used for reading and writing files and request services from the server program to each other. Next one is SSH. That's a secure socket shell. That is the one to be able to pass information remote computer and control them. It's similar to Telnet, but this time you are in an encrypted channel, and it is just like any other terminal, dumb terminal. Usually you'll just see the letters and numbers, nothing fancy. PuTTY is one of the ones you can use, for instance. SFTP is the way to secure file transfer protocols. One of them, SFTP, now encrypts the files that are being transferred instead of out in the clear. FTP was the original one because encryption didn't exist. So if you remember that, hopefully remember then that 2021 was that guy, which is FTP. Does anybody know who is SFTP? What is his number?
I don't think I ever knew that number, to be honest with you.
So if we play my little alphabet game and hopefully remember that SFTP came out second, 20 and 21 just got wasted by FTP. And they'll play this game all day. 22 is SFTP. It's also used by SSH. Because it's a protocol for encryption. Questions? Gotcha. So in the TCP/IP or the OSI layer, this one cuts the guy a little bit weirder for you. you'll see that it's more in high in detail depending on what it is itself. You have the OSI layer who does cut this up into 7 layers. Yes, I just said 7 flavors. So you start from the physical layer, which is actual, your cables, your connectors, your actual fiber, whatever it is. Then you have your data link, which is the actual MAC address, as we mentioned before, or Ethernet, or your actual MPLS, not MPLS, sorry, the frame relay we said earlier, right? And the actual link of the MPLS. But the network also of MPLS, the part where it's actually doing the quality of service for the multi-protocol layer switching, it's also in layer 3. Depending obviously on where it is, the next layer, which was the network layer, which contains the IP version 4 and 6, you also have the protocols of ICMP, IPsec, and ARP. ARP, as we said, was the address resolution protocol. Next layer would be your actual TCP UDP. If you notice on the right side of the chart, it's giving you what these datagrams or what it is called. In other words, what that area is called, those bits put together. On the one, we have your upper layer data. When it's on the transport, those are called segments. When it's in the IP, those are called packets. When it's in the actual data link layer, they're called frames. And then when it's going out the medium, it's called bits. Ouch, I know. So this is a different way where this is the OSI, the International Organizations for Standards. This is what was put out for the Open System Interconnect. This is their way of interpreting it. Okay, TCP/IP has those 4 layers that we just mentioned before. This also helps you if you understand which part of the OSI layer it's in. It helps you be able to go directly to where the issue is. You're able to identify where in the OSI layer the problem is, then you will be able to identify where the problem is. This is when we're talking about network problems. Now, as we see, this is just a small number of Class A public addresses. Everything gets reserved, and it is public knowledge of any of these numbers that are available to these people. So if you go and ask who is a public IP address, certain public IG address, there is plenty of sites who will answer who is this specific IP address and who it's leased out to. Questions? Now, on an IP version 4 network, obviously the subnet defines the network itself. So the different networks can communicate through the router, which is a default gateway. As soon as you're not in my neighborhood, the gateway or the router is going to send it out his WIC card. Therefore, the router is a physical divide that's going to help you logically divide all these networks and decide which way the network is going to go. But the switch itself, some routers have the capability, because they have a built-in switch, of creating VLANs. And I believe Cisco sophisticated routers also, which are managed routers, are able to create VLANs on the network. What are these? These are virtual LANs to be able to logically subdivide these networks and to obviously to reduce broadcasts and for security purposes, if you want to ensure that no one's able to crosstalk to these different VLANs, but maybe you have part of accounting who is in California, the other section of accounting is in Utah, and the last guy is somewhere in Atlanta. But each facility has all those different departments, and you really only want each department to be able to talk to each other. You can create VLANs across your intranet, and only those computers will be able to talk to each other unless the router itself allows it or routes the traffic itself. The switch will impede the traffic from actually happening. Sorry. Wow. Anything? No questions. survey says, here's your VLAN. So why would I want to do this? These things cost thousands of dollars. They're not cheap. Usually it's either 12. No, yeah, do they still sell 12? I think so. Those are ones that are managed as 12, 24, and 48. So if I only have a small building with so many computers, buying a separate switch for every single department just for security purposes would be very costly. Therefore, VLANs were invented to facilitate that. Only managed switches can create VLANs. Here you can see a virtual switch here on VLAN where port 2 is this VLAN, port 8 is this VLAN, port 10 is this VLAN. So any given port 2 on any of the switches within these VLANs are all configured that way. So that's why if you connect to port 2 on any of the switches that are created with this configuration, hence switch 1 and switch 2, it will be able to separate each of the VLANs to the specific area. Every port can be assigned a specific VLAN. Virtual LANs. It's equivalent to buying switches for everybody, for each department, and then only having them connect to the router. And if the router allows for it to talk, or if the switch is configured to allow crosstalk from one VLAN to another. What do you mean by that, Diego? I can create a VLAN for IT who can talk to all VLANs, but they can't talk to me. Or I can create a VLANs for all the servers so that everybody can reach the servers.
Couldn't this also be done with permissions?
Permissions are for authentication and for being able to authorize the use. But I can hack away at you if you're on the network. This is to stop you from being able to physically see me virtually on the network. Or virtually not see me physically on the network. There we go.
There you go. And do virtual VLANs, do they also have their own?
They can have their own subnet. They can have their own entire subnet or whatever you want, however you want to configure it. It could be the exact same subnet in each area. In that subnet, you only assign certain IPs to that area. It's all however you want to do.
Gotcha.
Your flavors.
And only the administrator has access to these VLANs, or it's just a switch?
The switch is a smart switch. It is a managed switch. Therefore, you must configure everything on it. You need to specify every single port. What VLAN does it belong to, and specify who they can talk to. What's the permission? What ports can talk? What VLAN can talk to what VLAN?
Okay. Marcus, question?
Nah.
Alvarez, anything?
This is just to save money and to add security on the local area network. This helps a lot when you're trying to save money and for security purposes. Next area we're going to review is the VPNs themselves, your virtual private networks. This is obviously to be able to talk on the Wild Wild West without anybody being able to hopefully be able to hear you. This is creating an IPsec tunnel or a peer-to-peer PPTP or an L2TP tunnel across the internet. What happens is the VPN server or the gateway itself will encapsulate it. Usually you have on your laptop some type of software that then creates a tunnel, and anything that's inside the tunnel is completely encrypted. As soon as it gets out to the other end, it gets decrypted and it comes out in normal to the actual server. The entire tunnel session is encrypted. No one will be able to see that until it gets to the concentrator, or to the server who is decrypting it, or the client, depending who's receiving the data, right? Any questions or doubts on VPN and what it's used for? It's to be able to talk over the internet without people being able to eavesdrop on the on my communication.
What is L2TP?
Layer 2 transfer protocol. LTTP.
Close. Layer 2 tunnel.
Tunnel protocol. Jeez, I was so close. Tunnel protocol. It is an encryption tunnel protocol. Layer 2 tunneling protocol.
Are each one of them specific encrypted protocols, or all of them just the same within themselves?
All of them have a specific port assigned.
Okay. Are these questions as
IPsec,
well?
PPTP. Oh yeah. You need to know what a PPTP port is, L2TP port, 1723, and was that 1756? No. I can't remember the second one. 1723 is the first one. Now I forgot the second one. That's what happens when you don't repeat it to yourself. You got to repeat it and repeat it. You're going to wind up forgetting it if you don't use it. It's just like if anybody learns a second language in high school and never use it. 1701 and 1723. Thank you. 1701 and 1723, right?
Hey, David, that site that you sent called Memory Palace, does it have the specific ports for these as well?
The books has the ports.
Oh, they do?
Memory
book should
Palace
have
is more
ports,
for a
yeah.
way to memorize things.
Yeah,
Okay.
it's just a technique for memory. You can use it for anything.
Okay.
All right. So here's against a song of what we need to learn of the mnemonic for safe technicians. Simple deeds help put immature hackers at rest. Hence, I never used that in my life. But if you like to play the game, this will give you an order to the chaos and hopefully allow you to remember that in this order, the numbers start to ascend. But I never played that game. I learned every single name with its port. It's the only way I'm able to do it. I can't play this. I don't know if I told you. I may be good in math, but English or any language killed me. So if you put letters and want me to remember nursery rhymes, I'm not good at that. The numbers, that to me, homes, I can numbers are very good.
Okay.
Side note, what's kind of sick, I'm pretty sure everybody that's old as me probably remembers their home phone number when they were growing up. But if I ask you to give me your spouse's phone number, you all are probably going to start reaching for your phone.
But this particular mnemonic, if mnemonics work for you, it's really
pretty
great in
good.
telling you, like, if you remember what SMTP is, and you know what HTTP is, and you know DNS is in the middle of that, you know that number falls in between there.
That's in the number, yeah. It's sending order. So this sentence lets you know in ascending order how they come, and then hopefully you can remember the specific ports that they use. Once again, it's a suggestion. It's not a mandate to remember the song. It is for the test to know FTP means 20 and 21.
How come that's the only one that's got 2 ports assigned to it?
20 and 21. One is to actually use for the authentication, and the other one is for the actual sending and receiving of files, if I remember correctly.
Which one is which?
I don't think they're going to test you on that, but I believe the first one would be most likely the one for authenticating. This is me taking a wild guess. And the second one is used for the actual transmission of the information. We could always look that up. Let's see. Yes, establish port 20. Oh, no, it's the other way around, isn't it? 21 is used to establish the connection between 2 computers or hosts, and 20 is to transfer the data. Sorry. So it's the other way around. 21 is to establish the communication or the tunnel, and 20 is to actually transfer the actual data.
We got a lot of different ways, like Diego said. Just the important thing is to take this and make it your own or use what's out there. But I got ways that I've learned certain ports, not all ports, but like Diego, 143, I love you, IMAP. That was mine before I met Diego. So we kind of got kindred spirits on that. But I've learned different ways to address different ports. 22, I say, shh. Michael Jordan, which is 23, will take you to the net, telnet. Like I come up with, you got to come up with ways to make it your own. It just depends on how you want to do it. So
SMTP, to remember what it does, send mail to people.
Send mail to people. Like
the only one that sends mail.
And that's exactly what it does. So I'm just saying that to not get so caught up on just you make it your own. And once you make it your own, nobody can take it from you.
Okay.
Everybody has their own way of memorizing and or learning these things, but we've got to continue to practice it and practice it. And I'll always say the same thing. I'm pretty sure some of you learned a second language or a third language in high school, and the majority of us probably never used it again and can't even remember how to use half of the words that we learned. Hence, my Italian is, I can only tell you, io sono un poco ritardati. That's as far as I can go, and I'm saying that I'm a little bit retarded, but that's very sick that I can actually remember that one.
Yeah, that's sorry to laugh.
But just all kidding aside, as you can see, if you don't use your brain and you don't repeat it and you don't continue to go over this information, it's not going to create that pathway. It's not going to sink in. There's no way if you think by reading this once, it's going to sink in. It's impossible. Unless if you have photographic memory, then that's when I start hating you. Because that's cheating, what I call cheating.
Not with this. I don't like this. Nah.
Okay, so hopefully by now we should be able to explain the purpose and the role of TCP/IP in the internet and the private network. It is the actual rules that make sure that everything has a purpose and a way. We need to be able to explain the characteristics and properties of it, which is the TCP portion or the UDP portion versus the IP portion of the protocol suite, which is actually we know as being the actual address or the network of the person, and understand the TCP versus UDP itself and the various common ports that are used and the service that they provide.
Jose, did you understand? Did you understand any of this?
Yeah, I understand.
That's what I'm talking about, Jose.
Maybe like a little hiccups, but I got the main idea.
Yeah. So I would strongly recommend going into test out and now going through that section. Remember yesterday we stopped, I think it was almost at Ethernet or something. Watch the videos, go through their labs that they're giving you, and obviously use the other videos that are available, either PowerSir or Professor Messer, to hopefully facilitate the process. And obviously the previous classes are also posted. Maybe somebody asked a question in those videos that you may have seen, but I would strongly recommend first using those other sources, see if they're able to explain it in different words that may make it easier. For instance, Professor Messer likes to explain IP as the same as delivering packages, and I find it that it is very cute the way he explains it, how the delivery truck gets there, and he does his little way of explaining on how the mayhem goes across the network. If you're able to understand a moving company and or how a delivery truck gets from one side of the country to the other, he will be explaining it in that way, and it is very cute the way he says it. It does break it down as layman as possible for those that understand the concept of labeling boxes that you're going to send from one house to another. And then when it gets there, those boxes that are labeled, they're all in one box. So they all got to one address, but each box has its own label. hence their own port, port 80, port 25, port 21, whatever port that you're telling me. Now I know where in this apartment, when I got there, where to take the package. Now that I took it to the room, I can let go of the package and sign off that I delivered the package to that room. If it's TCP, or just let it go and care less if I'm using UDP. Any other questions or doubts? 522. I would have to say I called the record here. Not mine.
Yeah.
I'm being able to torture.
Take a deep
Anyone want to
breath,
come up
folks.
for air? Anyone want to come up for air before I go ahead and drown you?
Yeah, no, I'd rather come up
Okay.
for air. Man.
You remember, use your study groups, lean on each other. If you're able to explain it to each other, you're using the other part of your brain. And if you're able to use that other part of the brain to explain it to somebody, you have completely learned it and no one can take it away from you. For instance, Christian, let me ask you a simple question. I'm not trying to be facetious or stupid in reference to this question. What's 2 times 4?
2 times 4 is 8.
I sounded stupid that I asked you that question. Why do you know that?
Because of repetition, saying it multiple times. And
At
also
home. Try that with a lot of the kids nowadays who seem to just be using calculators. They won't be able to do that with ease. It's scary that they won't even be able to tell you that 18 minus 4 is actually 14. I have a niece of mine who, unfortunately, my dad went up to her and said, "What's 1 plus 1?" She's like, 2. He goes, "All right, minus 2. Stop playing." She had no idea what the answer was. She got lost by the third instruction because she just used to using that calculator and not using her head. So please use your brain. Make sure you burn that into the pathways of your brain. The more you repeat it to him, the more he learns, just like you learn languages and definitions of words. There's plenty of words that I can spit out here that sound like German, but eventually they start being repeated to you that you're already understanding when I say DNS, what I mean by that. You hopefully also understand when I say a PIPA, that is Microsoft's way of giving you an APIPA address. Those are things, again, words that we're learning, mnemonics that we're learning, but if we don't repeat them to ourselves, our brain will forget, and quick. All right. I mean, it's up to you guys. I mean, it's really your time. As always, I love to leave the TAs with plenty of times to review any questions or doubts. It's up to you if you like to.
Get to learn TCP.
So folks, the
Marvin's
time
about to
that we
kill me.
were able to cut loose a little early last week, we just taking it all back today. So hopefully I think we probably broke even now, Diego. We don't have any more time on the back end anymore.
I don't mind the time. I mean, as long as I'm learning something.
Oh,
okay.
I like that. I get to learn TCP/IP.
There you go.
That's it.
I mean, no, it's very interesting. Perfect. It's real interesting. I'll definitely give it that. It's just like you said, I got to keep up with it and stay at it in order to understand it.